Hello, hello. All right. Always forget to turn the microphone on. Anyway. Hi. Today we're going to work on the cast, the programming language, again. But first, I'm gonna fix my bot because I merged the pull request by Nigel, and it broke it apparently. I should have tested before merging, maybe. Hello, Penguin. We're going to go to projects, CoolBot, go NeoVim. So git pull. There was an update, so I don't know, some things were changed. Hello, Pigorly.
Hello, Pgorly.
Hello, Pigorly. How are you guys doing? All right, let me just quickly fix the bot. You only do this for the lurky mode? I would do that too. I would do that too.
This for the emote.
All right, let's see here. Cast source main KS, right? That's what we want to. So here we go. We have a bug, cannot find returnable, whatever that means. When I'm compiling source main 163 over here, because we have a return here, but we don't have the with return keyword. It makes sense. We cannot return from something that does not have the return. We need to do with return here. Okay. Right, so what is this? Expected a type, got type. Wonderful error message. But we probably just need to say LXP restart. No? Type doesn't have fields. It feels like I'm using the old version here or something. Run reload. Maybe? Or maybe I pulled after. Yeah, I probably need to like quit and then reopen NeoVim. Right? Oh, Death Razor, hi. Okay, but the main thing that I want to see today is if I can do the higher kind of types in my language. It says me joins chat. Where is the bot? Hello? Oh, bytes read less than or equal to 0. Wonderful. Oh. Wait, I was actually disconnected from Twitch. Right. I think. Wait, hold on. Is my access token like fix? Is my access token outdated now? And we did not do the refreshment of it, right? Go back to Nix files, next Blake update CoolBot. Oh, Jerem. No. Hold on. Let me, yeah. My bot was not connected there. What if I do this? Well, Ogma. Get more token. Yeah, we need to, like, do this automatically, though, right? There is API to refresh the token, and I'm not using it here right now. Which, if the bot right now does not connect, then I need to I don't want to work on it right now. I wanted to do something else. But yeah. Until I use the old version of the bot to refresh or something. What was that? Okay, yeah, I cannot read any bytes because the connection is closed. Probably because the access token is outdated, I would guess. Make sure you create a backlog item for it so you can never finish it. I already did that, right? I'm pretty sure GitHub, CoolieMan, CoolieBot. There we go. There's an issue here. Refresh the token when needed, right? It's there in the backlog. I mean, how difficult is it to implement the HTTP, right? We need to do. I mean, this requires HTTPS, right? Probably. I cannot do pure HTTP, and HTTPS is more than just TCP. We could like expose the HTTP, like the HTTP requests from like the interpreter as a native functionality, though. Maybe. Can I just go to Project ScoobyBot and I can like git check out old Rust version? And can I like just cargo run? Let's try this.
Hello, Nigel Ithro.
Hello, Nigel Withrow. Nigel, I merged your pull request and bot broke, by the way. Because there was a compilation issue. And now the bot also cannot start again because I did not implement refreshing of the tokens. So I need to have a new token somehow. But I'm going to just use the old bot for now. And I will implement that later. Do you want my refresh script? Oh, you have a refresh script like written in Bash? Yeah, I guess we could do that with Bash, maybe. For now. The problem is like I just cannot do HTTP requests right now. Or I mean, I can do TCP, which means that I can implement HTTP, but I cannot do HTTPS, right? Without having a way to do that. Specify config. Twitch commands refresh token. All right, let's see. What is that? Issue an access token for Twitch. Home Twitch secrets. Response is this. Twitch refresh token is that. Twitch access token is this. Twitch access token, Twitch refresh token. You just store this as a file in your home. You already have the Twitch secrets. Why don't you just put this file? Oh, I mean, this is a file. It's not a directory. Okay. Yeah, let's copy this and change this a little bit. Fine. Okay, let's then check out the main branch again. Let's check out the main branch again. I can also like make this file be launched automatically, I guess, right? Let's just have for now over here refresh.sh, right? Refresh.sh, and then we'll just bin bash. That's wrong. usr bin and bash. Okay, first bug. Issue access token. Okay, source Twitch secrets. What do you mean source Twitch secrets? What is Twitch secrets? Response is curl ss exposed. Okay, client Twitch client ID, Twitch refresh token, Twitch client secret. Oh, this is just the env file containing these things. Okay, sure. Okay. How about I just like cd uvbot cd. I mean, I already am in this thing, right? I'm just going to cd.secret or whatever. I mean, never mind. Like we just source dot secret dot env or whatever. Just do that. All right, like right now I have home kuvibot.secret and I have all of these files, right? There are tokens here because I have like 3 accounts or whatever, right? But yeah, for now we just use one. You could inline it. Yeah, but I don't want to write this the secrets here, right? I also store this in JSON file. Let me look inside there. What's in that file? I mean, there is access token, refresh token, and scope, yeah. So, refresh token, Twitch refresh token. Wait, but refresh token is like, but then you also put it here, but you don't never source it. So you never use the new refresh token. Is that right? So the tokens and the reflection. Yeah. Twitch secrets. Oh, it uses this refresh token itself. Oh, like there's separate files. I see, I see. Sure. Twitch Nick, Bad Cop. Boom, boom, ba-da-dum, boom. So right now I have like this token. This is the access token, which is outdated, right? I think config toml right now actually contains the client ID and client secret. Yep. That's client ID and client secret. Is there something like JQ but for tomls? You should maybe refactor this. Yeah. Okay, fine, whatever. Let me just make these separate files. cd home kuvibot secret client ID is this. Client secret is this. And then token is access token. Okay. Yeah, you say we inline that stuff. I think inlining this makes sense. So if we have if the file exists, client ID. I'm just already in this directory, right? Or I mean, it's in secret client ID, secret client secret. secret refresh token, secret access token. Let's do that. Client ID. Doing Twitch. It's already like Twitch is cat. Secret dot like this. Twitch nick. Twitch nick? Where's Twitch nick used? It's not used, right? So we forget about that. We just have client ID, client secret. Refresh token. Client secret. Response. Refresh token. Grant type refresh token. Twitch refresh token is this. Twitch access token is that. Secret access token. Secret refresh token. Refresh token. Sure. Is that good? Let me see here. What happened to the bot, by the way? You changed something and it didn't work. It didn't compile because there was a return from a function that did not have the return, because there was a missing with return basically. It would tell it to you if you tried running it, like, because it yeah, it did not compile literally. You blame the unfinished language. Yeah, hold on. Neovim tokens will be bought. Let me just get my current refresh token. I'm assuming that this refresh token should still be working, right? Edit dot refresh token. I just do that. Okay. Hold on, is not re-implemented yet, by the way. You couldn't run. Yeah, but if you tried running, it's like, because it tries to compile before running, right? There is a compilation error there. It is not like reported properly though in the in like, you don't see it in the diagnostics in the LSP. I guess there is a bug about that because of the macros, but it doesn't compile even. Okay, but for merge it changed. Okay. Well, I was assuming that Nigel tried compiling it, but yeah. Okay, let's see. Do I just run this now, right? Do I just run this? Let me see here. Bash refresh.sh. Client ID unbound variable. Yeah, because I need to like, yeah, and to like go to Kubibot and bash hold on. There is a current working directory. cd Kubibot and bash slash refresh sh, right? Like this. Okay. We got secret. Okay, so I mean, I think this worked. Client secret. so I have a new refresh token and I have a new access token, right? Seems like that's correct now. And now I just now this should just work basically, right? CoviBot. Secret token, no such file or directory. Yeah, and now I think I want my bot to use the token. I say dot access token here, right? Yep. And I want to like run this automatically too,
Hello,
right?
Dev 9-inch nails ya.
I want to run this automatically. So can I just say something like std is this exec, you know, like bash. Well, I mean, then I need the refresh token too, right? Lake maybe. I mean, yeah, over here I already have like my bot is the shell script already, right? So I just say over here packages. I'm just running bash. I'm just running bash refresh sh, right? And that's it. And then I do that. Just put it on cron tab. I'm just going to run this before running the bot itself, and that's it, right? That should be enough. I'm just going to run this every time the bot restarts.
Hello, Flil.
Refresh token using bash. To do rewrite it in cast. Okay, let's do that. Hello, fly. Can you guys do fetch yet? What do you mean fetch? Well, I mean, yeah, that's what I was saying. I cannot do HTTP requests yet, right? I can do TCP, which means that I can implement HTTP myself, but I need HTTPS, right, to do the refreshment. We must do that, and that is not implemented. But I can like expose it as a native in the interpreter, like I said. But you know. Use OpenSSL CLI to do TLS easy. I mean, yeah, we can use the CLI. Yeah, we can execute like third-party applications, sure. Does GAML have HTTPS support? Yes, that's what I'm saying. I could expose it in the interpreter, which is it's right now not exposed. Basically, that's all. Cast TLS, yeah. Anyway, the plan for today is higher kinded types. Maybe. Oh, CoviBot joined the chat. See, it worked. First try. Did you hear about Mozilla wants to AI 5 Firefox further? Yeah, I saw that. You already switched to WaterFox due to that? HKTs, cast copy, Nigel Lang for sure. Well, I mean, technically, okay, higher kind of types. Let's say also dependent types. Question mark. Okay. Let me just commit that. And now we go back to the language. You don't want to get independent type mess? It's not mess. Like, dependent types is actually like simplifying things, I think. All right, so let's let's see here. Let's see here. So what we want is to be able to have monads, right? Like this. So right now this doesn't work because function cannot be typed, because this over here is a thing which is like a generic, but I cannot have this as in type position right now. But it doesn't matter. That's not the problem. The problem here is that this type contains FA over here, right? And FB. But what is FA and what is FB, right? This over here is not a concrete type. We don't know this yet because we don't know what F is. Because F is not a type, it's a higher kinded type, right? It's a function from type to type in this case, specifically. So this doesn't work right now. You only know C++ functor. Is that the same guy? C++ functor? I don't know. Forget about the functors here, I guess. Is there any other example of higher kind types? Hold on. What are some simple examples of HKTs? I thought this was like an ad. I mean, list T, option T, and promise T, right? But technically these are still concrete types. But list itself is this function. So functor is the canonical one. But what's the easier example? Like functor, monad, any other things? Anything else than functor and a monad that actually uses that? Functor is simple. What do you mean? I mean, yeah, it is, but it's something from math. Is there something from the real world? You know? C++ functor is when you do operator. Yeah. Yeah, that's not exactly it. Does Zig have HKTs? I don't. Well, I mean, so like, Zig doesn't have the type inference that we have. It makes it a lot simpler. So like when in Zig you are basically instantiating this generic, you already know what F is, right? But we want to work with abstract functors, right? Not with concrete functors. So Zig does type checking only when you actually instantiate this, not before, right? So that's the difference. That's the main difference. It makes the Zig the language a lot easier, but it doesn't do type checking of the code that is not instantiated. I guess, right? But like, we want to be able to type check the function, right? What's the function that uses a functor, right? What is the function that uses a functor? What's an example of function that generic fmap? But fmap is already like this thing here, right? So we can implement a generic function that uses this, right? But unwrap for all AB, ABB. Did you ever do C++ concepts? No. Well, I mean, I guess with concepts you can kind of like get the same stuff in C++ though. Maybe. I'm not sure. Like option int into int. That's not like that's not for functors. I guess unwrap is something which is its own thing, right? It's its own trait, unwrappable, because not every functor is unwrappable, right? For example, you cannot unwrap the IO monad, right? You can only execute it in the IO context or whatever, right? I'll give you an example of easy to understand HKT. Yeah, so we have basically unwrappable, right? Which is the type like this, right? Which has unwrap, which is T, which is, well, I mean, just we have T A, and we return A, right? I guess that's the definition of unwrappable. Concepts of Scanner, you give example syntax and tell the compiler everything that implements that concept needs to be compiled with that example. Yeah, I heard about that. I just didn't try it myself. Which means that you can write something like these things in C++, right? Yeah, so I mean, like I'm just trying to come up with something that is non-trivial, which would actually require the HKTs, you know? Like, because we can have the function unwrap, right? Which works. Wait, how do you like make this a standalone function, right? You have the like this is the unwrappable or whatever, right? Unwrappable T. Like if you have unwrappable thing, so you have the thing which takes T, which is like U int 32, for example, right? I guess we can do something like this. And this should return an int 32, right? Do a monoid. Yeah, maybe monoid would be easier. So this would be just like U as unwrappable dot unwrap T, right? So the question is, how do we type check this, right? Is the problem. Do a monoid. Yeah, let's try monoid here. Const monoid. So a monoid is what? Monoid is something that defines the operator, right? What is the operator called usually? Let's see. Semigroup with identity. Yeah, but like what do you call the operation? You just call it operator. And there's identity and, well, I mean, they just call the operation dot, right? It's just binary operator. which they just denote a dot. Let's just call it op then, right? So we have operator, which is t. Wait, is monoid an HKT though? Haskell calls it mapend. This is not an HKT though, right? Nerd soul. This is just a trait. This just has a, so like this is basically like type self, right? And this is a function like takes two selves and returns self, and then you have an identity, which is just self, right? This is not an HKT. Just do monad. Yeah, but like functor is the simpler one, right? So we just start with a functor. Anything else that is simpler? And what do we do with functors? What is some generic function that is just not fmap, right? So we can obviously just do like fmap, which is a generic one, over functor f, where we have like f. Wait, so now we have like ft, TU, it should return FU. Did you hear about Flix? Yeah, I did. We looked at that language, yes. Fs functor dot fmap. It should be the other direction. I mean, I think I like this being the first argument. Just fmap a or f, right? Wait, how does this? Is that the? How would I like infer what f is? Like if this is an option, for example, I'm not sure if this is the way to do a standalone function. I mean, we can always instantiate this explicitly, I guess, right? What about Flix? Flix is another language with effect system, which is interesting, right? And it has the best tool support. Yes. Let's see. Flix, higher kinded types. Pum, 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 pum. Does Flix have higher kinded types? It probably has, right? Yeah, for sure. Flix supports higher kinded types, and straight it can abstract over type constructors. T, type. For each. Oh, wait, for each? Well, I mean, for each is just like basically this is a functor, right? For each is basically the f map, right? Most interesting part is effect oriented system. Yeah. I plan to do the effect systems in my language too. I call it context system though, but the idea is the same, I guess. Yeah, this is just an effectful f map. Yeah. So we have a function which has effects, and then this is, yeah. And it doesn't, I mean, it does not return the thing, right? It does not return the new, the TB or whatever, right? which is why, right? But it is basically the F map. Shadow Crushers, what are you doing at night? Programming? Hi. Deriving type classes. It was somewhere over here, right? Deriving type classes. Enum month with ag order and toString. So this is just being derived. Instance toString date. All right, anyway, I don't know if I can come up with a simpler example than this. But the interesting part here is basically, as you can see here, in the type position, we have FT, right? What is FT? Right? So right now, we expected a type, but we got error, right? Why did we get an error here? Well, because F was expected to be a generic. But F, what is F here? We don't know what it is because we don't have the value. This is a value, in this case, which is going to be known only when we instantiate this function with the concrete, with F being some concrete like generic, right? Like option, for example. For each is simpler, I guess. Yeah, maybe for each is simpler. Sure. Let's. I mean, yeah, sure. Let's do for each. For each. We have container or whatever container. For each is basically we have a T where we have we have a container T, and we have F, which is like T unit range, and this returns unit like this. Sure. On what command you're working with now? I work on Codeforces. Sure. Let's do for each. Functor. Annoyed. Okay. So there's like two things here. First of all, I cannot specify the types of generics right now, which is why it's saying function cannot be a type. Let's start with that. And then there is going to be this, where we are trying to basically instantiate, in this case, the generic, which we don't know the value of, right? Like it's some generic which is going to be only available to us when this generic itself is going to be instantiated, right? So yeah, and that doesn't work right now. Let's do one thing at a time. Let's make generic types so that this at least can be, or I mean at least the what? Not the monoids. What is some trait which has like generic things? Which is not an HQT though. Iterator is a better name? Sure. Iterator. So by the way, what is the type of the iterator here, right? So normally it would be a type for our like things, but this is a higher kind of type, which makes that this to be taking a type and returning a type, right? So that's the type of iterator. That's what makes the higher kind of type. And this also, similarly to this, just doesn't have the syntax. Okay, yeah. Let's just do this, which will allow me to specify the type of like options, right? So right now when we look at like option, for example, right, this over here, that's the type of an option, right? It's it takes t, which is type, as an argument, and it returns the type basically, right? But we cannot specify this as a type right now explicitly, right? For example, I cannot specify what is sum, right? This should be like t, it should be t reference to option t into boolean, right? And this right now doesn't work. Right? But I should be able to specify the type of this. Enumerable, that's what you do in F# and in C#, yeah. You also have to fix annotating unnamed tuple in return type. Annotating named tuple in return type? Wait, what? What's the example? Annotating named tuple in return type. You can do that. .x int tries to look for x in scope. Where? In the return type? No. No. If I have a function f, which is a function that returns x in 32, then we just return here x is 1 to 3, right? There we go. This works. What's the problem? Oh wait, does this not work? Hold on. X is a type. Why is this a type? Well, I mean, no. No. That makes sense. This is defined over here. No. This works. What do you mean? That works. dbg print f x is 1 to 3. I don't know. Seems like this is all working. All right. First, we just types of generics. Okay. So once again, what I'm trying to do here is, do we have example which is generics? We do, right? Yeah, so what is the type of ID here? That's what we want to specify, right? ID is t into t, right? That's the type here. That is the type. I right now will require parentheses here too, which is also a little bit weird maybe, but yeah, let's fix that. So in order to fix that, we need to take a look at what my current types generic are, right? They are right now have the definition, which is a maybe compiled function. Sure. Definition is a maybe compiled function. Compiled function, argument body. I feel like this should be doable. I just need to make it work for the syntax. I want to have a type expression which is a generic, right? We say right now that function cannot be type, right? Function cannot be type. Yeah, but in generics, right? So this is technically not functions, this is the generic. But generic can be a type now, right? That's what we want. I'm programming in C, it's wonderful. Well, it's wonderful that you like it. If I would be programming in C, it would be hell. But if it's wonderful for you, I'm happy for you. Type expression. Okay, type expression. So here's what we're going to do. Here's what we're going to do. We have the argument and we have the body, right? So in this case, the argument is still going to be the pattern, but the body is going to be expression generic. Definition. Type expression. Shouldn't type expression be like the constant then? In this case, it's a little weird. We have expression generic, right? Definition. How is this different from a constant? Eval expression generic. I feel like I can just do a constant here. Copy pasta with function. Okay, let's just copy paste one more time. Let's copy paste one more time. We will return type expression where we have expression. Init type expression. That's what we return. And then expression is expression constant. Generic type. Init expression. It was unnamed. I was trying to return a foo b bar instead of foo bar. I see my problem now. Yeah. If it is unnamed. Then why are you trying to name it? So generic type is basically value. It's a value type. A value type. Generic type. Value inferred span. Right? Generic type is type generic. Type generic has the definition. Type inferred span. Right? And then definition is a maybe compiled function. Sure. And then we are trying to compile it here. We are trying to compile the function here, which means that I'm compiling the pattern as argument, but the body in this case must be a type expression. The body must be a type expression. So the body, but the body must be an expression later. Which means that Body is expression type. Do I have expression type? I guess I do. Expression type body into initialize expression span state. Like this, right? So we compile this as a type expression, convert it to expression, and that's it. Body. Well, I mean, the result here, type argument, and I don't need the type here, even. This is unnecessary, because we know that this is a type itself, right? So I don't need to do this at all. We just finish compiling to that. Okay. Is that all? Is that all? Let's see what's going to happen in generics here. So now it's going to say, so now this actually works, right? This actually works. This actually works, okay? I cannot hover inside of this though, but yeah. And then this says that type shape T type is not equal to this. T into T. Right. Wait, right. So because this is the type, generic, this returns a type. Right? Because the type of a generic is this, and this is the type of the actual ID function. Okay. They are not equal indeed. What do I do? Why did it try to unify them though? Why did it try to unify them though? Well, because I have this type annotation, right? But the type here is type. Hold on. Let's do this. Let's go into the interpreter and then say that like ID type is type this, right? No, and it's this in parentheses, right? So what is ID type, right? This is a type T type. That is not correct. Okay. Okay, we're gonna do SCADA system simulation. What is SCADA? Supervisory control and data acquisition. Never heard of it. So this is not correct because the type should be basically like T into T, right? That's not correct. That's not correct. Why is it not correct? Type expression. Because the body is me compiling the body as a type expression. Wait a second. It's because, wait, what? Maybe because my type generic. Maybe this thinks that the definition is the definition where the generic was defined, which is a different thing. Right? This is where it was defined, which is a different thing, right? If I have value generic, we have ID, name, and function. Value untyped function. What is a value untyped function? It's a maybe compiled function. which has captured and calculated things. Sure. Shouldn't I have like... You don't have to TT into T. Finally got Hyperland config working. Was harder than I thought. It was really nice. Nice. Hello, Veldeck. You don't have to TT into T? No, you don't. Although we should like support that. So like for dependent types, we need to do that, kind of. Like, you know, what is the type of like when you say the function type, you just have type A basically into type B. That's how you define the function type, right? But how do you define a dependent function type? You have like value A of type A, and then you return like B, which can use A as an argument, basically, in this case. Right? But if you don't use the A on the right side of the arrow, then what's the reason for you to give the name for it, right? You just do that, so we just shortcut it to this, basically. Right? Right now I allow that for the generics basically, but not for the functions. Eventually we'll need to figure out the syntax for it, because right now this is like if you say AA into BA, this is like, because I still expect a type on the left side of the arrow, right? But in this case this is not a type, this is a pattern, which is different, right? So when do I expect a pattern and when do I expect the type? Like if I still want to define my types of the functions like this, then on the left arrow this should be a type, but this over here is a pattern, you know? And then we have like the conflict in the syntax, because always specifying like underscore A, for example, this is too much maybe for defining the functions, right? Like what's the type of print, right? It's just string into unit, right? But if we only allow patterns here, you will say like underscore string into unit. I mean, technically it's not too bad, I guess. You always have like a name, right? String s into this. Maybe it's not too bad. It's just a little longer, you know? But basically almost all of the programming languages allow you not specifying the function names for your function types, right? Now you see that x, t, x in your language has syntax sugar for f. T, comma, and there is no comma in this case unless you write a comma after x. But yeah, right now basically on the left side of the arrow type, we right now expect a type expression, but you want this to be a pattern, and they are like, they look same but they mean different things. You know. Anyway, so why is this like that? Let me see how am I figuring out type of value shape. If I have a value which is generic, we have a function. Yeah, this is the definition. I see, I understand. Maybe I need to like change this then. Maybe I need to change this. So type generic, I want this to be changed. It should be not maybe compiled function. It should actually be this. I already have it commented out. The function, which is value untyped function. Because a generic type is basically a function that returns a type, right? Yeah. Which also has captured scope and everything. Yeah, sure. Let's go here. LSP support. So, but this means that in order to print it, I basically need to kind of like evaluate this as a thing. Let's just, yeah, like how do I print this, right? Because there can be any expression can be over here. T into T is just a single expression which creates the function type. But we could have other things. For example, we can have like if true, then T into T, else T. Although this must be like type expressions, right? Or whatever. This is something that should be possible, right? IDT is type that, right? Like this should be possible to write, right? If cannot be a type expression, not right now, but like at some point it should be possible. So how do I print it is the question. I need to be able to print the expressions. In this case, this is expression which construct the function type. This is kind of weird to grab dependent types people do. If true, then string, else int. Yeah. Yes, which is why I have the dependent types here on the to-do list. I think what I'm trying to do here is going to actually allow dependent types, which basically means that we need to have expressions as types. So right now my expressions, they can contain concrete types, for example an int or a function type, right? But we cannot, and we can also contain like variables which don't have the values right now, for example t's, right? But sometimes, for example, for higher candidate types specifically, right? For higher candidate types, we have this thing. This is an expression which is basically a function call, right? But we cannot call this function until we know what the f here is, which means that this is just an expression. This is a concrete expression, which is like, I mean, I call this instantiation of generic, but it's basically a function call. But what's the reason for me not to support all of the expressions at the same time? And that is what is allowing me the dependent types, basically, right? Because if I have the like function f, which takes like n, which is like int 32, and this should basically return. So like I should like be able to like return the type, like I don't know, like let's say fixed sized array of n plus n, right? Like because we don't know the value of n, this is how we write the type anyway, right? And this type contains this value, which is just something that we cannot evaluate, this is just an expression that we can only evaluate once we know the value of n, right? But when we specify the type, this still is just an expression, you know? So I see that this is no different than this thing, which basically means that I need to have types which are expressions, which need to be evaluated later when we know like the variables that the expression contains, right? Generic. Okay. Printing the generic. Function. In this case, I have function which has definition, which is yeah, just let's say definition and whatever else. This untyped function. Isn't there like typed function? Yeah, value function is a typed function. Yeah, sure. We just match definition compiled. If it is compiled, I know the argument, I can print the argument, but what about the body? Body is an expression, and I don't print the type of this. I actually want to print the expression here in some simple form. Is the idea. But let's just say over here to do for now, because I'm not sure how to do that yet. Let's just write it to do. Okay, so we have a generic type which has function A, and we have function B. So how do I know that these generic types are the same? We have two functions, right? We have two functions. Which so the definition of the function, so the function here is the untyped function, and I need to be able to unify untyped functions then, right? Yeah, so we don't have a when, we just say unite untyped function AB. Sure. So how do we unite untyped function? Unite untyped function. Untyped function unite. Its value untyped function unite function span. Like, how do we type check this? It basically means that two functions must be like identical, right? How do we know that two functions are identical? That's the question. How do we know that two functions are identical? we just look at their body and it must be the same, but it can be like something similar which is written differently, you know, which is why I think what we should do is we should be able to evaluate the function using variables which don't have values, which we call bindings, or they're called free variables in the type theory, I guess. So we just evaluate and then we see that the value is the same. Which means that inference might require evaluation. So we have one more point of recursion in our language. Type inference might require evaluation. And I cannot do that right now because I'm inside of the type library and not inside of the interpreter. Interpreter is something that knows how to evaluate, but this does not. And now I need to like merge these libraries together because it is recursive now. Or I can just store it inside of the value untyped function. Not inside the value untyped function, you know, inside my generic types, because that's the only thing that I want for now, at least, to work. We have type generic. This contains the function, but I also want to like basically know how to print it, right? Which is the function evaluated with the random thing, you know, without the values. I don't know if that makes sense to anyone, but evaluated with bindings is basically a value. Well, I mean, since this is the type generic, evaluation should result in a type, of course. Yeah. So when I print it, now that I know that there is like evaluated with bindings, evaluated with bindings is literally what I'm going. So like I don't care about the body then, right? I just say that this is my argument. I'm printing the pattern here, and types. I think like types should be. I don't know. So instead of to do here, this is just literally going to be print type evaluated with bindings. Now I know how to print it. Okay. All right. So I don't have unite and type function. Let's say unite type generic. Type generic. Just say over here A, B, generic, unite, type generic, span AB. So how do we unite the functions, right? How do we unite the functions? So like in this case, because if I'm trying to unite them, it means that these functions should be identical, which means that it doesn't matter which one I use. So I just say that function is function A. We literally don't care. We literally don't care. Google search AI. In type theory, a function equality means function equality means two functions are equal if they produce the same output for every input in their shared domain. Yeah. That's right. This leads to two main perspectives. Intentional type theory focuses on definitional syntactic equality, same code computation, while extensional type theory, like homotopy type theory, supports function extensionality, stating that identical behavior implies equality, treating propositions as types. So basically what I'm saying is that if we have function, something like this, we have function t, and then it returns like, I don't know, and it has code like this, like let result be t into t, and then we return the result like this, right? So this is the definition of this function. And then we have the other function, which is like, I don't know, like let's say u, and then it just returns u into u, right? Directly. So as you can see, the definition is different, but if we actually try to run this function and we try to run this function, then the result is going to be the same. So what we are doing here, what is this evaluated with bindings? It is basically I'm trying to actually call this function with some abstract value x, right? So in the first case, we are just trying to call this with argument x, right? So we just evaluate this, and we get as our result x into x. We don't need to know the value of x, but we can evaluate this right now, like this, right? And then if we evaluate this, where u is equal to x, we also get x into x. So that's how we know that they are identical, basically, by actually evaluating this with abstract arguments. So yeah, there should be like equal by functionality, yes. Because this is a function that describes the type of the function, which is dependent function, I guess. So because the type of the result depends on the arguments. How complete is that though? I don't know. I mean, obviously we cannot always evaluate the functions. We cannot always evaluate the functions, right? Like in this case, I can evaluate that. But sometimes we have like an if. For example, we can have like an if t is equal to int32. We cannot know if these things are equal until I actually know what t is. Because sometimes it's equal, sometimes it's not. Which means that this is like not going to work, right? But it means that this over here should basically be the result. Right? Or something. I don't know. Wait, you have functions which produce types like in TypeScript? Yes. Wait, do you have that in TypeScript? Do you have that in TypeScript? You don't have that in TypeScript. Function, you have like, I mean, it's a special like function type expression maybe, or what is it? The simplest way to describe a function is with a function type expression. No. Kalindra, hello. How long have I been taking to write my language? I started it like a year ago, a little more than that, and I've been working like this is the rewrite number 3. Already. I have solved the advent of code fully with my language, and my Twitch bot is working right now, and it's written in my own language already. Soon I hope that I will start like self-hosting next year. I just want a couple more things. So right now I'm looking into higher kind of types and like this kind of thing. If I can figure it out, that would be really nice. Although technically this is not necessary for the self-hosting. Yeah, I don't think TypeScript has that. So like we are treating types as values, which is normally the feature of like dependently typed languages. And languages with compile time evaluation like Zig, for example, can do that too. Not sure. Hold on, let's see. TypeScript, higher kinded types. Do you have that in TypeScript? Higher kinded types in TypeScript. Is this what you mean? Here are a few first order types. U, X, U into T. No, that's... This is zero order types. This is first order types. A simple map. You're searching what you've seen? Yeah. Maybe you mean this? So like it's not a function, it's a function on the type level basically, right? That's what your higher kind of types are usually. Because you don't treat types as values. They live in their own world. So you have like the distinction between a function that returns a type and like the type, which is a higher kind of type. We want to blur that distinction though. But yeah, basically this is it, right? So you have a function f here. So this is an argument to your generic type, and this is itself a generic thing, right? So you instantiate the generic with argument x, which is the first argument of your generic, right? So that is something that I guess is called a higher kind of type. F over here is the higher kind of type. You can convert both functions to normal forms and then compare them by content. Lambda calculus has normal forms. Yeah, I guess. Yeah. But basically, I think what I'm doing is like by evaluating, I basically convert it to a normal form automatically. That's why I called it evaluating with bindings here. Because I think that's what is resulting in normalization. Hello, Weidhoven. What are we doing today? I'm looking into like implementing higher kind of types. So like monads and functors and stuff like that. So yeah, anyway, let me just try what I was doing, and if it doesn't work, then I will think more. But yeah, since we are going to check that the functions, so like this is my normal form of the function, right? Evaluated with bindings. If they are equal, then the definition that the function has, we don't care which one to use. They are interchangeable, so we just use the first one. But we just say that evaluated with bindings, this is something that must be unite, right? So we just say unite type, evaluated A and evaluated B. We are saying that they are the same. But also these functions, right? These are compiled functions, right? I need to maybe also say that like at least the type of the argument is the same, right? Probably would be nice. Can I spawn here? What's my opinion on Haskell? I there was a brief moment where I was trying to write my language in Haskell, but I rage quitted because I didn't like how they implement the record types. Like, it's a nice language, I think, but it's at the same, like, I like it and I hate it at the same time, kind of thing. The idea that it's a pure functional language also is nice, but I'm trying to kind of achieve the same thing as Haskell does in my language, which is far from like being implemented. But the like monads in Haskell allow you to like the monads in Haskell, they allow you to enforce that a function only has certain side effects, basically, kind of, right? You basically, a monad is a way to describe the side effects, right? So I'm trying to do the same here, but instead of it being monads, I'm trying to have an effect system where we don't treat the function themselves as pure. Hello to Much Tomato, by the way, and thank you for the raid. How are you doing? But as I was explaining, I'm making my own programming language, and it's supposed to be like pure in sense where all of the side effects are controlled. So when you look at a function, for example, here's something from the standard library, right? Like let's look at the networking library. When I connect to a TCP socket, this has an effect on the outside world, right? So in a language like Haskell, you would have this function return the IO monad, right? But what I do instead is I say that this function still just returns a stream, just like in a normal language. But we say that this function can like access network, for example. So that if you want to guarantee that the code that you are writing is never going to access network, you can enforce it, actually, is the idea. It is very similar to monads, but it's a different solution. There are a bunch of like new programming languages that do that, including the Flix, which was mentioned by someone in chat earlier today. It's a similar idea to monads, but it's a lot easier to use, in my opinion, for like without having the PhD, I guess, which is what you need to be able to write Haskell. Yeah. Yeah, I'm making a programming language because I don't know how we got into this. I was trying to make games, and then at some point we started making a programming language for no reason, and we're now deep into it. Maybe eventually we'll start making games with the programming language. That's the goal, at least. How was your game? Did you release it? The Forklift? Sounds like my situation, making games and randomly making a programming language. You released Torso Tennis? I don't think I saw that one, Torso Tennis. I saw that you're working on Forklift all the time. What is that? Why is Steam not opening? Torso Tennis? has the same style as your forklift game. Is this multiplayer? Single player. I'm trying to look at all of the this thing, and I don't understand. Like, is this? It looks like a card game, a deck builder. Is this a real time or a turn based? I don't understand. But I'm bad at understanding things in general. So yeah. It's like action roguelike. Thinking of adding 1v1. At least like local multiplayer maybe would make sense. Would be easier to make here. That's common feedback? That you don't understand what it is by looking at the trailer? Alright, so maybe I'm not that bad at understanding things then. But yeah. Alright. What are we doing now? What was this? Alpha conversion, basically. What is alpha conversion? Alpha conversion is the process of renaming the parameter in function abstraction. No. So like, if you want to figure out that two functions are the same, renaming the parameters is just one thing, but you also need to like normalize the body of the function to know that the function is going to behave similarly, right? But this is another thing that so here's what we're doing. We have two functions and we want to know that they behave the same, right? So we want to do the alpha conversion to here, which is why I call this evaluated with bindings. Bindings is basically values which don't have a value. It's a weird thing, right? But yeah, basically I'm going to replace every parameter with a new value, which is going to basically result in this renaming. Exactly. It's a little weird the way I'm doing things here. I don't know how to explain it. Full beta equivalence. All right. Well, someone knows all the terms. Beta equivalence. Yeah, I'm not like deep in the theory. I'm just doing things that as I feel like they should be. And we've gotten pretty far with it, I guess. But knowing what things are called is nice, I guess. This is a one-step relation between the terms of the lambda calculus. This relation is neither reflexive, symmetric, or transitive. The equivalence relation is the reflexive. What? What is beta equivalence? Beta reduction. Lambda calculus. Where I should... there is a like equivalence here, right? In lambda calculus in general. Beta equivalent lambda expressions. Plus 2, 3, and 5 are beta equivalent, right? Because if we evaluate this and we evaluate this, we always get the same thing. Yeah. What's the definition of this beta reduction? Yeah, there are several notions of equivalence and reduction that make it possible to reduce lambda to the equivalent lambda terms. Alpha conversion captures the intuition that the particular choice of a bound variable in abstraction does not matter. And beta reduction rule states that a B redex, an application of the form, reduces to... Okay, I'm too dumb to understand this, but I think yes, I think that's what we're doing. Alpha equivalence basically looks same, bindings can be different. Beta equivalence is behave the same way, but not necessarily looks the same. Yeah, we want the beta one because it's better. Beta is better, right? Unite type. This expression has type generic, which is not a function. It cannot be applied. Okay, so yeah, I kind of like, let's have a to do here. To do fork and enforce type of function A and function B argument are same. Okay, what is the type of the generic what is the type of the generic function? It's a generic. We don't have the definition anymore. We should instead construct the new function given this definition. Yeah. So how do we do this? Here's what we do. We have a new function. Type generic. I want to like... shit. I will like, once again, I am like I have a recursion in my dependency tree. It's no longer a tree. We have a cycle here. This is my inference, and it depends on evaluation now. Type of value shape. Like, in order to know the type of a value, I might need to evaluate something. So I think like, how do I do this without making the entire language be written in one file? I have once again this problem. Last time I tried to solve this, I ended up not even trying to implement the feature anymore. Because that's very annoying to do in OCaml. Hello, Elemental Magic's card game. Is there an example you could show of the array thing that we were talking about? Array thing that we were talking about. Yeah, let me remind myself here. I don't have this implemented yet. I only have the idea, but yeah, so we were talking on Linda's stream that well, this is basically about the placement new stuff, which is available in C++, for example, right? But not in Rust. So when you, let me just try to explain the problem here quickly. We have I think like more generally, the thing is not even about the arrays though. So like when you have function main and you have something like this, that boxed value is box new value, right? So this means that there's an allocation happening, and then we're going to put the value into the heap. This is a more generic problem than just the arrays, right? But arrays are just like this. You have a vec, which is like vec 1, 2, 3, 4, right? So what we want to do is we want to not allocate this array on the stack and then copy it into the heap. We want to initialize these values directly on the heap, right? But this is a more generic problem where this value right now semantically is being constructed on the stack and then being copied into the heap. So what we want to do instead is to construct this object directly on the heap. So this feature is called placement new in C++, I guess, and in general in place construction. Maybe modern C++ features in place construction. Maybe like that's what you want to look into. But my idea for solving this is that instead of having like box new thing, which takes the argument which is already available to you on the stack and then it puts this value into the heap, instead you say like box new, which is a function that returns the pointer, right? So this is the pointer to not initialize data, basically. And then you say that pointer is equal to value and whatever. So you first allocate and then you move the value in, which is a little bit longer. I have macros in my language, which means that this can be like shortened out into basically this same original syntax using macros. But you are not going for macros, so. But basically, this is the idea of the out pointer, is to be able to have references to not initialize data. And then similarly to borrow checker, it is going to check that before using this value, you must initialize it. Kind of similar how you already can in Rust. If you have like let x, you can already do that. And then like you cannot use it immediately unless you actually initialize this. So it is very similar to this already. That's my like rough idea right now. But yeah. That's not what I'm doing today though. But hopefully you understand, Kalindra, what I'm trying to go for here. I'm far from implementing this though. Still a bit out of context. Why are you checking for semantic equivalence anyways? Okay, so what are we trying to do here is we are trying to we are trying to be able to write higher kind types, right? And what I'm trying to do, actually, I just maybe like in generics in general, right? So we have the function ID. What is function ID? It's a generic function that works for all types T, where it takes the argument x of types T and returns x, right? That's the ID function. How do we describe the type of the function? It looks something like this. It's a type which is generic over T. It takes T and returns T, right? So, but what is the difference between this, which is the definition of the type, and the definition of the function itself? The only difference is that this is a generic, which when you instantiate, you get the function. And this is a generic, which when you instantiate, you have the function type. So the way my language works right now, my generics are basically just functions, which take this as argument. This is a function that returns the function of type TT, and this is a function that returns the type. So in order to type check that the type of this generic and the type is equal to this type, which I'm specifying here, I need to figure out that the type of this generic is equivalent to this type. And since this is a generic type, which is basically a function that returns a type, I need to check the equivalence of the functions. Does that make sense? What's the highest kind of type? I don't know. I don't know. The top type, maybe? Don't you need sub-variables with types and check signatures? So the thing is, once again, the generic type is not just like, this is not a special form, right? When we say like argument and into like value, this is basically a function. This can be any expression. This can contain an if. For example, we can have type t, which says like if t is equal like to int 32, then we return like t, and otherwise we return tt, right? This is so this is the type, you know, which like we can have anything here. And we can have any expressions because this is just a function that returns a type. In this case, it returns the original type. And in case if it's not an int32, then we return the tuple of two types, which are the argument here, you know? Can expressions have side effects as well? Well, right now I'm not checking for effects. Eventually we will make sure that they are not having effects though, yeah. So these must be pure functions. Yes. But I am not checking for this right now because I don't have the effect system yet, but it is planned. TypeScript has some of that stuff. They have conditionals at least. Can you show me? Like someone was looking for this already, right? Like, can you show the example? I thought the way this normally works is t is an implicit type argument, and then you see that what you can instantiate to get the type equal to t. Thus, all the arguments to your type level functions become implicit arguments, and you try to make them as generic as possible. Wait, what? The way that normally works is t is an implicit type argument. Oh, no, well, that's how it works in like. You know, so in Haskell, your type arguments are implicit. In my language, they are explicit though. So I don't do let polymorphism. And there is the paper by the creator of Haskell language, which is called this let polymorphism. Let should not be generalized. So I don't want to have implicit arguments. Let should not be generalized. This over here is the paper by Simon Peyton Jones, which is the creator of Haskell, I was told, right? Which basically says that let polymorphism is bad, which is implicit like t's. We do explicit t's instead. In Idris, you have implicit arguments, but you can also specify what they are. Yeah, at least right now, my idea is to have these things always explicit. Let's see what this is. Conditional types. At the heart of the most useful programs, we have to make decisions based on the input. JavaScript programs are no different, but given the fact that values can be easily introspected, those decisions are also based on the types of the inputs. Conditional types helps describe the relation between the types of inputs and outputs. So yeah, you have a type which is a conditional, yeah, which basically means that this type is an expression which you need to evaluate, right? I mean, in this case, you evaluate this immediately, right? But this should be possible to do in a generic context, right? Like this doesn't make much sense because we already know this, whether the dog extends animal or not, because we see this implementation directly, right? But when you're writing a generic type like t, and then that can return like if t extends animal, then number or string, right? But yeah, this is basically I don't see this in the examples though. Careful, Govi, this peak guy likes Haskell. Oh no. Hello, peak. No type defaulting. Wait, what is type defaulting? There is a certain defaults that I have on types, which is, for example, when you see the literal 1, 2, 3, it defaults to an int32, but you can do a type annotation which will result to it be inferred as a different type. Is that the type defaulting that you are talking about, or something else? In Idris, you have implicit arguments. I'm not sure if that's true. Let's see. Here's my Idris. Here's my Idris. I was pretty sure that you cannot. How do you do type inferencing currently? Well, I just do. You like that as a user? Program language creator says that it's annoying, but as a user, it's helpful. Yeah. It is though annoying as a language creator though. Yeah, I agree. But I'm trying to make a language that's good for the users. I'm not trying to simplify the language. Implicit arguments are important for dependent types. I'm not sure that's true. You can have explicit arguments because the values that index a dependent type might have a dependent type, and that type might have indexes which themselves have a dependent type and so forth. In implicit arguments to bring them into scope and reference them. I don't understand. Rust does have type defaulting, so even with inference, it won't default to a type. Well, Rust has like the instead a dedicated like integer type, which is specifically for integer literals, which also defaults to like int32 basically, right? But if like in Rust, you can say let x i32 is equal to 1 to 3, and you can say let x i64 is 1 to 3, and then you can say let x be 1 to 3, and this is going to automatically be dbg std any type name or something std rs type name of val, I guess is what I want. Type name of val x, like this over here is going to automatically be inferred to be an int32 because that's the default. I need a reference here, right? But this basically defaults to i32, but if I say here i64, it's going to be changing the type to a different type basically, right? Isn't that the same? Does your example with t is equal to int32 produce type like t or tt? No, the type itself contains the if expression. That's different, no. The type is literally if t is equal to int32 then t, otherwise tt. And you can only like know the concrete type when you know the value of t. So yeah. Which means that like once we infer what t is, then we do further evaluation. But if it's just or, no, not exactly. So consider a simple example where you work with a vector foo. Let's try this in address. You have foo, which is vect and a into vect and a. Here n is an implicit type, but actually we can go further. Yeah, but why? But like this is not necessary, right? Wait, you're saying this is necessary because you cannot say that this is like something that takes n, which is I guess nat, right, into a, which is a type. Like, isn't this the full form of foo then? What if we have a context where we have vector of variables in scope? Ooh, context VAV here is vector, so what we really have is foo and nat a type. Yes. The important thing here is that a lot of times the implicit arguments are erased, so we do not want to pass them, but we want to reference them in our type. Yes, so like that's why. So in my language, I guess maybe this is the main difference. In my language, like you still have this as an implicit argument, right? You have implicit argument n, which is nat, right? And you don't want to specify them when calling this function. That's why I'm having a distinction in my language between functions, which is something like this. Function is just like x into x, right? And generics, and generic is like this, x. So the difference is that this is basically can be erased, but you can also instantiate it explicitly, and this function must always be called explicitly, right? So for example, when you have a function parse, right, which has a type like for all t is string into t, right? When you call the function parse, you can just call it with 1, 2, 3, and you get like an int32 as a result. Right? But you can also specify that this function should parse an int32 explicitly. So I guess this like curly braces is the alternative of the I guess this is just like an implicit argument, but I just call this generics for some reason. But yeah, kind of the same thing, I guess. So implicit arguments, they are not always implicit. They have the possibility to be implicit, in which case they are going to be inferred. So when you don't specify this is an alternative to saying like parse with underscore, and underscore means infer this, and you can just omit this entirely. Yeah, but it's technically is passed at compile time. It's just the compiler is inferring what is this implicit argument, right? It's not defaulting, it's inferring it. So like this already works, right? Cast git stash cast. So you have like, let's use std prelude star, right? So we have function string parse, right? Let parse space string parse, right? If I say parse 1, 2, 3, and I say like let x be, let's say this, that function f is a function which returns x, like this, for example, right? To make it like more obvious, I guess. So if I try to see the type of function f, then this is a function that returns something that is not inferred yet. But if I say that function f is function that returns like an int64, for example, which is capital int64, right? then type of f is this. And if I try to call the function f now, it is going to return 1 to 3, right? Because the definition was this. So like now this is parsed into an int64. We could do the same, and we can say that f is function that returns a float 64. And then if I call the function f, it is going to return 1 to 3.0, right? This is not defaulting. This is based on the actual inference. And yeah, basically parse is the dependent function which has the type, which is the type that it's returning, being passed implicitly to it, right? So the full form of this is parse t, for example, right? And I can, but I mean, in this case, like we can say int64 here, or whatever, float 64. But in this case, it's being inferred. This is quite different from Haskell. Haskell also has the syntax for explicitly naming your like argument, like I don't know what they call them. They don't call them implicit arguments. And I mean I don't call them implicit arguments either. I'm just calling them as generic arguments, because this is a generic or whatever. So in Haskell, when you have a polymorphic function, once you define something, it gives it a type, and you cannot refine the type. No, you can do that in Haskell too, right? You can do that using type inference. Isn't this? No, I think Haskell does it the same. It's just, so in Haskell, your parse function is what? It's like for all a string into a, right? That's the type of the function parse in Haskell. So for me, I just write this as like, you know, t string into t. And when I call the function parse in Haskell, if you want to explicitly instantiate this, I think the syntax is like at float or whatever. You cannot come by later and say parse string into int. Can you not? I think you can. Hold on, is there a Haskell playground? Like, can you not do type ascriptions anywhere? Can you not say something like you say that like parse is I don't know, let's just say this ID. Let's just go into GHCI maybe. I don't know. At some point I will actually work on my language though, right? Instead of looking at all of this. Nix shall GHC. Yeah, let's download 200 megabytes. Like I'm pretty sure you can do type ascriptions. Like you have ID, which is like ID X is X, right? What's the type of ID? If you leave it like this, the ID is going to be like for all A into A, right? Which is this is the most explicit form right now. But if you don't do this, and if you say something like function foo, which is, I don't know, let's say ID 1 to 3, isn't this going to infer the type of ID to be like int into int? And you can also, I'm pretty sure that you can do the type ascription here, which is ID is int32 into int32. Pretty sure you can do that. This is like, I don't know, ID2. It's not called int32, just called int or integer or whatever. Right? Like, that's how you do it in Haskell. Int is native, integer is infinite precision. Yeah. So, I mean, that's just what I did. This is just the interpreter. I just say that I want to evaluate this, and I just type ascribe this thing, which is similar to doing it in any other place, like in Haskell here, right? Anyway, so now in Haskell, the difference in Haskell types live in their own like world, and in our language the types are values. So when we say that we have this for all a into a, this over here is an expression which this basically is a function, right? ID is basically a function that takes t and returns which it takes t, which is type, and returns t into t, right? Which is something that you cannot do. So this over here is an expression, and this is the argument of the function. So what we want to do to type check two ID functions that they are the same, we need to figure out that this function right, so this is like ID type is basically, what do you say, like lambda t into tt, right? We want, so this is the function, and we want to see if this is equal to the other type of some other ID function, right? For doing the type checking, which means that we need to check that the functions are equivalent. Okay. In Haskell, I guess you can do it locally, but for what you did you globally set the type of the function. It is the same as doing it locally. I don't have the notion of global things. Also, like in Haskell, everything can be described in any place. So I can, like, local and global doesn't exist. I don't have the distinction like that. I think in the literature they use capital lambda for the type arguments. Yeah, maybe like different languages do it like differently. Also, independently typed languages, what I've seen is something like, you know, you have t, which, I don't know, you have t which is type, which returns t into t, right? So, and this over here is the function that does not only specify the type of the argument, but also specifies the name of the argument, so that you can use it later, which makes this thing itself a dependent type. So this is a dependent function, because the result of the function depends on the argument, right? Anyway. Yeah, let's see if I can make this work. What's this? Beta normal form in untyped lambda calculus. Clean star. Okay, that's too much for my brain. I can understand some things, but not that. You have a good idea, you forecast and remove the types, and then it can be good. Yes, in Idris, the generics are also dependent function types. Yeah. Yes. So the only distinction that I'm making for generics and functions, technically, is the fact that generics are functions with arguments that can be removed. So they can be called with the argument being implicitly inferred. That's the only distinction. Otherwise, functions and generics are the same. Is the idea here. Although right now I am doing them a little bit differently, but eventually that's the idea. Because there are also like some syntactical questions that I want to address. You can understand Idris, but not basic lambda calculus. I have not written a big program in Idris, so I don't think I understand it, right? I have I understand it in theory, but not in practice. In practice, I don't understand it, right? What are we doing here? Just LSP support. Okay, so yeah, I just have the simple problem here right now, right? Because I over here try to figure out what's the type of a generic. In order to know the type of the generic here, which is just a function, right? I want to basically rewrite. Here's what I'm trying to do right now. If I have a generic, right? Once again, we have a function ID, which is like t x t into x, right? This is a generic ID function. What's the type of this? In order to figure out the type of this, what I do is I just rewrite the function into like this. ID type is t into type of this expression. That's what we do basically. So this is the type of ID. It still has the same arguments, but it's a function that returns the type of what we return in the original function. So we construct this, and then we want to type check that this over here is equal to like this over there, right? So we want to figure out that this is equivalent to this. Which means that I'm trying to I'm going to try and evaluate this with t still being a free variable. Which is basically going to normalize the body of the function. That's what I'm trying to do. But that means that I need to have the evaluation here. But I have the cyclic dependency problem because evaluation is defined in the interpreter module. But this over here is a different module. Can you not already reduce type of this to TT? Yeah, I can, but I can, but I'm trying to make a more generic solution, I guess, right? I mean, type of type of is basically going to be TT, which is a constant though. Which is so like the difference, I guess. There is a difference here because the type of this is a constant t into t, right? And it is different from, so like this is different from t into t, right? Because this is already evaluated because I have compiled this function and I have inferred this type to be t into t, right? So I infer that this is t into t, which is already like the function type as a value. And in this case, it's a function type as an expression, you know? So this is not evaluated yet, and this is already evaluated, I guess, is the difference here. So this is not evaluated, is what I mean, because this is an expression, and this is a value, which is a type. Does that make sense? So I need to evaluate this one too, and then compare them, is the idea. So how do I turn this into the evaluated thing? I evaluate it. That's how I evaluate it, by calling evaluation. Because I literally have the expression, which is called type expression function. We have type expression function. So here's the interpreter, right? In interpreter, I'm trying to evaluate the type expression. We have a type expression, which is a function that takes the argument and the result. So we literally just evaluate the argument, evaluate the result, and return the type, which is the type of a function. So in one case, it's already evaluated. In the other case, it is a thing that still needs to be evaluated. That's the difference, right? Okay, so how do I do that? So first I need to rewrite the function here, which also needs some other things. Like it feels like the type of value shape and like I also need to like compile the thing here, which is a different one. V generic function. You know what? How about maybe like in order to break this cycle in the dependency, I'm going to, in my generic values, since this is already a value, I can already store the type. So the type of a generic, I'm just going to initialize it in the other place, which is going to be type generic, you know. And now I just need to initialize it. Now I can initialize it in the other place. Yeah, that works for sure. That works. So the type of the value generic is generic type. I just already have it stored here. Nice. T generic inferred type, generic type. There we go. That works. Substitute type. This probably is incorrect, but okay. Wouldn't this be a problem in traditional language because T into T would be written in a separate type language? Well, I mean, yeah. So in your normal programming language, that's why you have like separate language, which is like the type language, right? This wouldn't be a problem. Well, I mean, yeah, I guess it's not a problem there. But it is less flexible as a result, right? It means that you have two separate languages. Yeah, and we are trying to unify these two languages into one language. Which simplifies the language, right? Okay, substitute type shape. This has function T generic evaluated with bindings. It doesn't simplify the language designer struggle. Yeah, I guess it doesn't. How do type inference work currently? What's the infer type for a any? Length a. If type of a is string, else math pi. Hold on. Let me try to understand what you are trying to do here. You are trying to say that we have a any. So first of all, I don't have the any type currently, right? Which means that you probably want to say that a is of type t, where this is a generic function which takes t as an argument. This is the how you do the function, and this is what we return. The length is else that, right? So you say that if basically t is equal to string, then we return string length a, and otherwise we return math pi, right? Although math pi is not necessarily of some generic type, right? So this only works if math pi is of type t, which is a generic, which is not, right? It's of a concrete like floating point number type, probably. Simply return type depends on the input type. I mean, yeah. I cannot do this right now, but this is supposed to work, right? Because in this case, like in this context, we know that t is no longer generic, so this should type check, which is basically like we need to figure out how to do that. I don't do that right now though. Yeah, but I want to have something like this working. I do have some variation of Hindley-Milner, but we don't have let polymorphism, which I guess is not exactly Hindley-Milner. And in Hindley-Milner, interesting. I mean, yeah. In which case you have to do a lot of work to achieve what you're trying to achieve. I mean, but I mean, this is similar to like generic algebraic data types, no? Like, for example, like because yeah, this is like similar to the generalized algebraic data types, where when you perform like basically the pattern match, or an if in this case, which I guess should be like basically match t with, you know, if it says string, then we return string length a, right? So inside of this, we know the type of t, which means that this type is different. It is very similar to GADTs. But yeah, I need to like look into how to implement that. There are some issues with the inference of GADTs even in OCaml. Not sure if they're better in Haskell. Because I never used them in Haskell. Right? Like when you have the generalized ADT, right, where you have expression, this is not a GADT yet, hold on. Over here, this is the GADT, right? So you have an expression which is of a different type based on the constructor that you use, right? So when you have evaluate over here, isn't this very similar? So you're like, this is basically over here the pattern match. Or can you do this in Haskell only by like having separate like function like implementations? Like can you not do that? Let me try this actually. Hold on. In the Haskell playground. I'm interested now. So we have a GADT like this. And this is the thing, right? So this should I must have a main IO is return pattern matching on GADT without monolocal binds is fragile. Suggested fix: enable any of the following extensions GADTs. Wait, I can specify GADT without having the extension enabled. How do you enable the extension? Oh, this is enabled. Yeah, I have GHCI now. I don't remember what I tried to do there though. Do I just do this? Language GADT z. Okay, there we go. So like this now will have this with no warnings. Okay, sure. So I'm just like, what if we instead say something like this? Eval expression is case E of, is that how you do it, right? If it is I, n, then n, is that how you do it? I don't remember. And you have B, then B. Yeah, this doesn't have the warning that the pattern match is non-exhaustive, but like this is the same, right? Because when you normally have the case expression, the type is like, so like in this case, the type is integer, and in this case, the type is a Boolean. But these types are not being unified, right? So we are going to basically need to do the same for, what if you remove 10? I think this is going to, it could not deduce that P is int from the context A is int. Wait, what? This cannot do it. Let's do this fully. Actually, let's just do that. We only have two variants here, right? Could not deduce P is Boolean and from the context A is Boolean, bounded by a pattern with constructor B Boolean expression Boolean. In a case alternative, P is a rigid type variable bound by the inferred type of eval expression A into P. I see. Yeah. So like it thinks that it returns a single type, but it doesn't, right? Because the return type depends on the thing. And it cannot figure that out, I guess, in this case. Yeah, so there are still some issues here which require explicit annotations, it seems. Similarly to OCaml. I wonder why this is required though. Like, can it not figure it out? Well, I mean, yeah, like in order for the inference engine to not try and unify these two variables, the two results types of both case branches, right? It needs to know that this is a special case of a case expression or whatever, right? Similar to whatever we had before in that example. Yeah. Yeah, we'll see. We'll see when we get there. Let me try to continue and actually finish this result. T generic function evaluated with bindings. Okay. Function. This is basically a reading stream. No. Hold on. I mean, yeah. Good night, but I'm no longer going to be reading anything. I'm going to log in and I'm going to and I'm going to and I'm going to implement the thing now that I have in mind. Type state value bindings. I'm not an expert, but I think the whole idea of HM inferencing is to try to unify the possible return types to the least general type possible. Yeah, but like you are not doing this in case of the GADTs, right? So yeah, this is definitely something different. Very similar to the facts that we return a different type based on the argument type, because this is literally the same, right? But yeah, we need to like think about how, like, when do we try to not unify these, right? When? Sometimes we unify and sometimes we need to not unify, basically. But we still need to be type checked. Okay, so we have the interpreter now. Generic. When I instantiate the generics, I don't really care about the type of a generic in the interpreter. If we try to evaluate expression generic, so yeah, this is where when I actually construct the generic, this is where I'm in having this as, okay, sure, type. Okay, let's figure out what's the type, which is type generic. What this is, so we have evaluated with bindings, and function is type function. Okay, and type function is types maybe compile function, right? Okay. Maybe compiled function. We have compiled and uncompiled. Well, I mean, I think technically we have the definition here. I guess when I create this is the function, value untyped function. Value untyped function. Definition. Should I do this for all the functions eventually anyway? So should my function, which is a value untyped function, contain the definition, which is a maybe compile function, which returns the type immediately? Which means that this is my expression, right? Expression generic should have definition and definition type, which is another maybe compiled function. So I'm going to initialize this in the compiler then, right? I'm going to create the function itself and its type. And for functions, maybe we don't do this for now. Expression generic. Def type is maybe compiled function. Okay. What's the error? Syntax error over here. So I have a definition, I have definition type, right? So this is a maybe compiled function, so I already have that. So function here is definition type. No, this should be value untyped function, which is very similar to the actual value, right? Right, so I say ID is ID gen, because we need to like also capture the things here. Definition is definition type, captured is state scope, calculated natives is hash table create 0. And evaluated with bindings is this function which I need to evaluate. So yeah, this is type function. Type function is this, which is value untyped function, right? Okay. So evaluated with bindings is, what is this? I need to actually evaluate this here. How do I do that? How do I do that? How do I do that? So I need to basically to assign a new binding for every binding in the original pattern that we have, right? Evaluated with bindings. Let's see. Let evaluated is type new not inferred. But then we basically we need to wait for this function to be compiled and then execute it. So yeah, we say type function definition compiled is this await compiled. Now that this is compiled, this is option. What does this return option? Option unwrap or else. Not compiled, something something. Let me just return the error here. Just have to do here. Let's actually just like, you know, fail. We'll see if it panics. So I have a compile function which has the argument, the body, and we don't care about that. So now I need to do first the alpha reduction, I guess, right? Which is all the arguments should be renamed. Okay. So argument is, yeah, and it's like actually call this function, right? Call, and to call untyped function, value untyped function. Well, I mean, isn't this what I should call? Call type function. Okay, hold on. I need to call untyped function. Yeah, but I need to like construct the pattern, which means that I need to wait for it to be compiled anyway. So I call untyped function, type function, substitution mode. Substitution mode is none. I'm not sure. State type function, and then the argument, right? So what is the argument here? That's the real question. So to construct the argument, which pattern matches with the pattern that I have, right? Okay, so like I want to like have the normalized pattern or something, right? Yeah. So I want to say that argument is construct normalized bindings argument. Let's call the function like this, of a compiled dot argument. That's what I want, which is a pattern. Call untyped function is going to return the type, right? So this is a result. A result must evaluate as a type, right? So we say result value expect type. And this option unwrap or else function fail to do eval expected type. Just panic for now. So this is the actual type that we have. result. This is a type result. The result is a wait, this is a value into value. Why is the value? Sub mode. Oh, span. I forgot the span, I guess. So yeah, result now is a type, and I need to say that if like I need to, so this over here is that stuff, right? So I say evaluate inference type expect inferred as a result, and that's all. So now how do we construct the normalized bindings argument? That's the question. So what's the type of this here? We have a pattern, and I need to basically construct a value based on the pattern, which contains the bindings which are normalized, right? So that if we take two patterns which are of similar shape, we have the same value basically, right? That's what we want. Function pattern. Okay, right, so let's see how we would do this. We are going to match pattern shape with, so we have different patterns, right? We have pattern shape. Can I like help me deconstruct this? Yes, that's what we have. We have a pattern placeholder. If we have a placeholder, then we don't care what the value there is, right? Yeah, we don't care. If we have a placeholder, then it means that this argument is not going to be used in the result at all, so we can put any value here. Like we don't necessarily need the same value, we need to construct anything, right? So we basically can return value new not inferred. So because yeah, we don't care about what the value is. And the span here, span. If I have a reference, to say films, hello, how am I doing? I'm doing good. I wish I made more progress today, but we were just talking about things. Sometimes talking about things is important, which it can lead to more understanding. What are higher types? Higher kinded types is what I'm looking into, which is basically like type functions, I guess. For example, what is the type of an option, right? We have or what is the type of an array? So you usually have something like, I don't know, array of type T, right, in your languages. So array T is a type, right? But what's the type of array itself? This is basically a function that takes type and returns a new type, which makes this the higher kinded type. And then we want to also be able to pass this as an argument to other things, right? So when you have like, I don't know, you have like monads or whatever, right? And this basically is something like this. We have the type function as its argument and return a type. So when you have a type function as the argument, that makes it a higher kind of type, I guess, right? I don't know. Have you ever worked with something similar? Do you know what a monad is? Reference. All right, I don't know about this. Okay, but if I have a unit value, new not inferred of type. Oh, by the way, I also need the type. I always need the type, right? New not inferred of type. span pattern data type. Right? Hello, they used unsafe Rust in the Linux kernel and they got a CVE because of it. Time to replace it with cast. Yeah. Sure. Not yet though. Not yet. Give me a little bit more time. And then we replace everything with cast. Of course, sure. Reference. When I have a pattern which matches a reference, it means that I need to construct a reference, right? Value reference. So this is the inner pattern. So we'll need to have a reference to the thing which matches this pattern, right? So we need to construct normalized binding span p. This is going to be, the references are references to places, and also we need to have mutability there, right? So place is place in it. Like so. And this is going to be value inferred. We have a value reference which has mutability also, right? Mutable is just false for now. Okay. Place is place in it. This needs mutability. Mutability in this case is going to be inherit, I think. I'm not sure. But this is how I do a reference. When I have a unit, we can always just have a new not inferred of type unit. By the way, this is type. Type is pattern data type. I feel like we need to like substitute the bindings here because this is not always going to be correct. If I have a tuple, and we have a pattern tuple, we have error. In case of error, we just return the error. If we have a variant, pattern variant, label span value, and to create value variant, label span value, label value variant has a label. It doesn't have label span. It has data and has type. Data is value option map. Yeah, so in this case, into map this to construct normalized binding span. Right? Yeah, I think that's correct. And then we just need to define the type here. Variant type is type expect variant. Type. This must be inferred for me to do that, right? This expression is type value option, but expression with value of type place option. Oh yeah. Because like value, and then I need to put that value into a place. So we say map place, and it mutability is going to be inherent like this. Okay. So tuple now. Tuple. Tuple patterns are interesting. We have now like parts there. We have parts including unpacking of the tuples. But they all match but they all are patterns, right? Or whatever. We have parts. Parts is a list of pattern tuple part of. Okay. So I need to construct a new tuple here. Let result be value be let tuple be and to create value tuple. Tuple value inferred span tuple. Value tuple has the tuple and the type. Type is tuple type, and tuple type is type infers type shape expect tuple into option get to, right? Like this. So now what's the tuple? Tuple is tuple. We are going to construct it here. We're going to start with an empty one, and then we do parts iterate. So here part is pattern tuple part. So if I have the part, tuple part is either a field or an unpack. So we're going to match part with field or unpack. If I have a field, we have a label, span label, and field. So this is a field pattern in this case, right? Then we say let member be match label with none. I need to have a name here, right? If it is yeah, it is just like label option map label get name, right? So then I say tuple is tuple add name and then the value, where value is construct normalized binding argument, where the pattern is field pattern, right? And we have unpack. We have a pattern, so I can construct a new one here, right? Unpack packed pattern, right? So we have we will have packed value, which is going to be construct normalized binding R expand packed pattern, and then I need to like unpack this. Shit, what did I do? Tuple is, and to like add all of those, right? So I need to do packed value. So this one must be a tuple, right? So we do value expect tuple option get tuple iterate function. So I have a member and field, right? We say that name is match member with index, then none, and if name, then some name. And then we say tuple is tuple add name value. This over here is value. What's wrong now? This expression is type value tuple, but expression was expression type value tuple. Value tuple field is what we have. So value in this case is field place. Field place must be claimed. So now what do we do? Expression has type value tuple, but expression was expression of type tuple field tuple. That's right. Oh my god. I need this to return the value. This is a value, right? So field must be value tuple field, which must have place, which is place init inherit value. Mutable false. No, we don't have mutable. No, we have something else here. What do we have? We have place, we have span. Span is label span. And we have type field. Type field is, what is type field? Type and label. Type is field pattern type, and label is just label, right? Field. So I add the field like this. So in this case, I just have the field and I add it as is maybe, so I don't even claim it or whatever. Does that work? Maybe, potentially. So now when I have the binding, this is the interesting part, right? So now we basically have a binding and we want to replace it with other bindings, pattern binding. This has by ref though. By ref. By ref. No, it doesn't matter. It doesn't matter. So like we just construct a new binding here. Like in order, and the order should be the same. So I should like have so when I'm constructing these things, I am seeing some bindings in my pattern in order, and I need to get the one by index, which means that this function probably should have the index or like the state of me constructing the bindings. But I mean, the state only contains the index, right? So let's say index is going to be the int ref. Maybe that's what I do. So we have index. So in this case, I need to... I don't care about what binding here is, right? But I just say... Okay. Say by ref and binding is underscore, just to like, and like we ignore all of this. Just in case this is being refactored later. So... I will say index is index plus 1, right? But I will return a new binding. Not a new binding though, from scratch completely. Like I need to have like this set of bindings. But it also depends on the type though. It also depends on the type. This is weird. Like, how do I make sure that it's like, yeah, if I like, because the bindings, they don't only contain the names, they also contain the types. If I use the same one in different places, then the types are going to be broken because, yeah. Wait. Yeah, how does that work? How does that work? Maybe, wait, hold on. I just need, wait a second. I think I know. We need to like use this binding still because this binding contains the type. Right? So I need to, anyway, so a result is going to be a binding. We return that. So what's the binding? This binding is a pattern binding, and this is the actual binding that we have. This one must be binding, right? So binding has what? Binding is a type which has all of these fields. Let's see, do I just construct it in this place? So ID is going to be I don't know. We have IDs, name, span, type, label, and mutable. All right, mutable is going to be pattern binding dot mute. Label is going to be pattern binding dot label. Type is equal to pattern binding dot label. Span is equal to pattern binding dot span, or is it not? Or is span the new one? The name is also, so yeah, the name I guess is the different one, right? Because the symbols. So I need to like have the list of symbols based on I indices. So we like always go like A, B, C, D, E and stuff, right? Symbol. Label. Wait, but that label is also... Wait, hold on, I have labels too. That is wrong. Type. This is type, by the way. ID. Do I create a new one, though? What? How do we define equality for bindings? If all of these things are equal, which means that the IDs also should be equal, right? But that is very, very weird. Maybe I need to like override the equality here. Span label. But the name and a label, I should just create a new label, right? Labels are only used for the LSPs for refactoring though, so maybe this does not make much sense. Label, create, let's just create a reference, span name, you know, and the name over here is going to be symbol create name, right? Is that what we do? But this should be like, yeah. How about we do this? And normalized binding name. Normalized binding. Normalized binding at index is going to be int into binding. How about this? Function index into. Can I do that? I want to construct these only once though, so I want this to be like a lazy one somehow, you know. Can I say over here like let created or like, I mean, it's like a cache or something, right? Yeah, it should be like a cache. Is it like an array? Can I resize array? Is there like a resizable arrays in OCaml? Array, because I want it to be array add append. I mean, I guess I can just append or whatever. I mean, we use arrays for fast indexing here, right? It's going to be still a reference so that I can change it completely. Array init, array init returns a fresh array empty. How do I construct an empty array? Is that not possible? Array make. How do I create the empty one? Is that not possible? I mean, or I can just construct so that it's enough, you know, array. Let's do this. Let's just init. Let's just have 100 or whatever. Like we never will need more than 100 variables in our patterns, right? Function index into, so like this is going to return a binding, and the function itself is just going to say that if we have index, we just say array get cache index, right? Yeah, and it's just going to throw an exception if we have more than 100 for some reason. Yeah, so over here we just return id is id gen. Where's the syntax error? Where's the syntax error? Oh, over here. Okay, so I say that binding cast cannot have empty arrays. I can have that in Python, not cast or camel. I can do anything I want, but I don't have arrays at all right now. I don't know what to call this. Normalized binding blueprint is normalized binding at index. There we go, that's what I want. So have id is normalized binding blueprint id. Name is a normalized binding blueprint name. Label is normalized binding blueprint label, but the type, mutability, and span can be new ones, right? Wait, no. The spans cannot be new ones. The spans must be the original ones, actually, because otherwise they will not be equal. And I must make them equal. Normalized binding blueprint span. Yeah, but the type is different. And mutability. But does mutability actually matter? Because like maybe the mutability does not matter. Can I just say that mutability is always true? But if I don't use the mutability, it doesn't really matter, right? Yeah, I guess it doesn't. Let's do that. So what is this here? We have ID, we have name, we have... my god, we have all of these fields. Name is symbol create name. Where name, so name is just going to be something like this, int to string I, and then like I don't know, let's call this like the I don't know, let's say _0 or whatever. That's a good name, right? Span is span. Let's say that span is span fake normalized binding or whatever. Type is just type new not inferred span, but we are never going to use it anyway. Label is label create reference span name, and mut is true or whatever. This also does not matter. Okay, create reference name. Okay, does that work? Construct normalized binding args. This expression has type index. Yeah, so I should give it index too, right? Okay. So construct normalized binding args. This one over here is like the implementation. This over here is the implementation. So this should actually, yeah, maybe we do this. Let rec impl is this function, and then we just return implementation with ref0, or with the index being ref0, you know. So this over here is going to call implementation recursively instead of construct. Right, this is impl index. Let's rename impl to construct still. So I want to shadow this thing actually, so that I don't use the other one on accident. Type pattern index ref int ref span. This should return value. The kind of expression is not allowed on the right hand side of a let rec. Wait, what? Which kind of expression? This kind of expression is not allowed on the right side of let rec. What's wrong with this one? Which kind? Like, this is just a function. Can I not have a recursive function here? What? I don't get this. I don't get the error here. I should definitely be able to have recursive functions. Right? Like let rec have is this, right? Wait, this kind of expression is not allowed as a right-hand side of a letter. Wait, what? Why can I not do this? It's because OCaml language server is showing me the errors that don't exist, of course. Of course. Stupid OCaml. Once again. So yeah, this just needs index. Right. The value arg. Yeah, so I need to span here now. I need to span, evaluate generic, and this, wait, hold on, no. This still, this kind of expression is not allowed. What kind of expression are you complaining about? This is just a function. OCaml. This kind of expression is not allowed on the right-hand side of a letrec. What kinds are allowed there? I mean, the only kind that allowed there is a function, right? The body of a letrec must have a functional time. So changing loop to loop everywhere ought to fix the problem. I mean, I have a function, yeah. I have a function, hello? Hello? Let me do this. Flat track, construct, normalize binding args. Index is I'll just say that I just do value not inferred. Span. Who is higher type? It's like there are low types and then there are high types, you know. And yeah, the one that's high is higher than the low one, right? Kinda. Like this works, and this literally is the same. But yeah, we're talking about higher kind of types here, which is generic types, basically. Type constructors. What's the type of a type constructor? What's the type of a generic type? It's a function, basically, which returns a type. This works. Okay. Why does this not work then? If this is the same. Okay. Does it like infer that it's not a function for some reason here? I don't understand. Ah, my god, why is OCaml so annoying? This kind of expression not allowed. Which kind? This is index ref into span, into pattern, into value, right? Yes. Yes. I don't understand this. This is stupid. Here's what I can do. I can move this function over here, and it's just going to work. If I just say over here end, because there's a bunch of recursive functions, this makes no sense. Oh wait, these kind of, wait, what? What is this error now? Wait, what is this error now? Oh, I see what you mean. It's like on the right side of this. This is the recursive one. That one was okay. Okay, now that makes a little bit more sense. The error was very wrong. Yes. Makes a little bit of sense now, though. So we just say over here, let track. Bum. We're just going to have a function here, right? So function span pattern into. I think I don't even need these spans and patterns now. Or whatever. Or I can construct this function over here. Span pattern. Now that works, right? Okay. And f is going to be, I don't know, let's call it simple, whatever. Okay, anything else? I think this is okay. Now, compiler. When I initialize the expression, which is a generic, expression generic now has the definition type also, which means that we have a type generic, which now has this thing, which is the value and type function. This over here is a maybe compiled function. Wait, type generic should have that. T generic, type inferred. What is this? This is me trying to infer the type here of a generic. Yes. When I construct the generic, what's the type there? This is before I construct it as a value. Okay. This is before I construct it as a value. Does it mean that maybe like this over here? Or what, like expression generic. Evaluate expression generic. This is where I'm specifying the type here, right? So type is type generic. So this over here should, I think, be extracted into generic type. Generic type is basically this. It depends on the definition type, basically, right? It must have the scope too, though, right? So this has type state into maybe compiled function. Into type generic. Is that right? And span, I guess. is also needed. So I just say that type is generic type span state def type, right? And then I can call this function from the compiler too over here to say that type generic here is interpreter generic type span def type, and then the state of the compiler, so the interpreter is state interpreter, right? Does that make sense here? I don't know. And when I instantiate the generic, this is where I'm trying to infer the type, which is the result of me instantiating a generic, which basically means that I need the generic. Generic is an expression. Type generic is generic data type inferred. So this is the type generic. Yeah. Type generic have function and evaluated with bindings. Since this is evaluated, I can just substitute it though, right? Or I can call this function again. It doesn't really matter, I guess. Function evaluated with bindings. But yeah, this is the other binding, so I need to like do it again, right? So function is a value untyped function. Definition, await compiled function definition then, right? And then we do all of these other things. I think this is correct. Not sure. Okay, and then the core syntax. When I create the generic type. What is this? This is a type expression. Type expression. Oh, when I'm creating the generic type as an expression, right? So type generic is just a function. So I need to give it the definition, right? I need over here to give it t generic, and then this should be interpreter generic type span c state interpreter and definition. But what's the definition? Definition is this may be compiled function. We evaluate the type. I mean, yeah, that's. Wait, that is it. Exactly. Okay, I think that is correct. Okay, and then expression generic definition, and then over here we need to have definition and definition type. Definition type is the other compiled function. Okay. Definition type is a separate compiled function, which once we calculate this, finish compiling definition, right? Yeah, we're going to also here, we're also going to compiler finish compiling definition type, which has the same argument as the definition, but the body is a new expression, which is a expression. The result is none. The body is a new expression, which is expression type. Expression type, which, okay, expression type in it. Type expression span state. Expression type has it's not even expression type. This is expression constant, which is the type, and constant is value type, and type is the body data type, right? value inferred spec. Is that correct? Then this is the initialized expression. This expression should not be constructed. The expected type is state t, because this should not be named, right? Yeah, there we go. Okay, and now we have just the LSP. LSP, what are you saying? LSP, we have expression, generic definition, definition type. It's going to be ignored, I guess. All right. Anything else? Okay, success. If I'm successfully compiling, doesn't mean that it works. Probably not. I don't expect this to work, but who knows? Let's try it. Restart the language server. Does it just panic? It does not just panic. So what does it say? Trying to compile error node. I mean, yes, this is an error node. Let's see. Yeah, this is like a bunch of things that I was doing here. Okay, type shape underscore 0 is not t. Okay, so as you can see here, what's the type of what's IDT? What's IDT? Let underscore IDT is underscore. Let's see. So this is so yeah, there we go. So t returns underscore 0 and underscore 0. So I have evaluated this expression while I was assigning t to underscore 0. This makes sense, but this is incorrect, right? Because I want probably to replace it now back underscore 0 to t. I want probably to replace this back so that we still say t into t, right? Yeah. Okay, but what's the type of the ID function if I don't annotate it? In this case, the type here is t into t. Why is that so? That is not correct, right? Like, shouldn't this also be underscore 0 into underscore 0? It means that I did not do anything. Well, the reason I did not do anything is because I was returning a constant here, so I need to substitute the bindings or whatever, right? Okay, what are you now saying? Type shape underscore underscore is not equal to type. Number literal inferred as string. What do you mean? Something is wrong here. Let's just do it from scratch. If I have ID, which is this, the type is that, which means that I'm printing the original one without this being substituted, right? Okay. Generics, no, interpreter. I want to go to interpreter core. Generic type. We have type function. Result. I'm calling the untyped function here, right? I'm calling untyped function using the argument, which is constructed with normalized bindings. So when I call that function, since I had t being the argument here, call untyped function should substitute. Oh, wait, hold on. I say substitute mode is none, right? And this is not correct. Substitute mode should be not none. We have type only, function only, or full. I feel like this should be like full here. Maybe. Okay, so what's the type of ID? Now the type of ID is t0 into 0. Okay. Because t is now equal to 0 when we're trying to normalize this, which means that it's going to be equal to this one, right? So can I just say now IDT? And this now type checks, right? This now type checks. Okay, now can I print ID hello world? I cannot, because it says type shape underscore and underscore, which is a function, is not equal to type. Why is that? Why is that? Can I say this? Okay, let's do it one thing at a time then. Let's say that let underscore be equal to id to id. Let's start with that. So this is the same type t and 0 into 0. But if I say id int 32, then this place is not initialized. Int 32 not found. Could not find in uppercase int 32. Okay, so this is going to be a type. But why is this a type? That is wrong now, because okay, yeah, it's because I changed the representation of this. I understand now. I understand. It says the type inference of me instantiating the generics, because I was changing things. So when I instantiate the generic, what is the type? The type, I know that this is the function, right? Definition. And I don't need to have definition type anymore, right? Like this compiled function, this is my, like, I don't need to do that anymore because I did that in other place. So yeah. Argument type is expect inferred as this. Argument is evaluate argument. Do I need to evaluate the argument though here? I'm not sure. Generic type interpreter. We have some to-dos here. A compile is some def. Generic type value. Untyped function. Wait, why do I need to do that? The result is I need to call untyped function. Substitute mode is type only, span, generic type interpreter, generic type argument. So generic type is the thing, which is my function. Like, isn't this the function which is already the type? Yes, I just need to construct the argument into, like, infer that the argument is the same type. Argument, I just evaluate that. Generic type, like, I don't need this anymore, right? I'm just going to call the function, which is, we already have the function, and then the function must return a type. That's all. Okay, I think this is going to work now. Maybe. Please. So this is now a function that takes int32 and int32. If I say id string, then this is going to be a function that takes string return string. This is int into int, this is string into string. Okay, nice. So does it mean that everything here is now going to work? This seems to work. This seems to work. Can I uncomment everything here? And it's going to work. This over here is expected. I'm pretty sure this error is expected here. What does this say? Number literally is inferred as string. Okay, number literally is inferred as string because const2 is const. Hold on, what is const? Const is is a generic A of type A, B, A. So it's a function that, like, takes two arguments which are carried, and it always returns the first argument, basically, right? Yeah. But since I'm using the, wait, but why is it inferred to be string? Number literally is inferred as string. Goes to a string into string. Because this it should be a function that returns a string. Because I'm using it in string parse. That makes sense. Yeah. Let me just check if I do git stash. I want to check that it was working before, showing the error here. Yeah, it was. Like, I'm pretty sure this is correct. Whatever, this example is weird, but okay. Yeah, it's supposed to error out here. Okay, and now let's actually try the higher kind of type. If this works properly, if this works, then it means that I can actually write a monad, right? So let's see. We have expected a type got error. Expected generic. Okay, let's see. Functor. Let's comment everything out except for the functor for now. So what's a function? Expected type got error. Cast. Cast example generics. No, not generics. Wait, hold on. Generics. Yeah, that makes sense. Cast examples monad. Camel run param like this. Okay, so it says that this is expected to be a generic, but this is not a generic because this is a thing, right? Because I actually evaluate this right now, I think, right? Let me take a look at my types expression instantiate. Instantiate generic is a thing where generic is an expression, right? Okay, can I see where this is used in the core syntax? Instantiate generic. Generic is compile expression generic, right? Okay, it says expected generic while evaluating this, right? Oh, it's because I'm trying to wait. What? Why am I trying to evaluate this though? Why am I trying to evaluate this? Oh, yeah, no, that's right. This is not enough yet to do full higher kind of types. All that I did for now was to be able to specify the types of generics. That's all. That was long, but I actually did that, I think, right? But now, in order to have the higher kind of types, I cannot evaluate this immediately because we don't know the value of f yet, right? This is some abstract f. So what is the type, which is fa? Fa is like, we cannot reduce this further. This is fa, and that's all that we know about it, right? And we can only, like, expand fa to a concrete type once we know what a concrete generic this is, right? But all I know about f is that the type of this is like t type, right? Where t itself is a type. That's all that we know here. So now in order to store this, we need to have basically expressions as types. Yes. Okay. Progress was made though. I can still have these things as my arguments, but I cannot use them. I cannot evaluate this. Like if I have something const foo, where f is t, type, t is type, right? Something like that. Type into type. Let's say this const type into type, which is basically like this in Haskell, right? It's type t type into type. So that expected type got error. Wait, this is the type. Could not find type into type. It should be uppercase. So F is this. And then like I just want to like call this, right? So like, can I just say F argument, where argument is actual type, right? Like this. So this type checks, right? Because this now is basically a function that takes a type function and the type, and then just applies it, right? This, yeah. So when I say, for example, that we say that let underscore be of type foo instantiated with a function. Let's say that the function itself is like string, the type itself is string, but then the type is id, let's just say id, right? Where id type into type is tt, right? I can just do this. So this is the id type function, right? And so this is going to be just a string now, because this is just apply, right? So apply is the thing that takes the higher kind of type and a type and then just applies that, basically, right? So this is possible already. What is not possible is just to have this over here as a type, because that is something that is not possible to evaluate until we know what f is. That makes sense. Okay, I think I can commit that though. Let's just call this type function, right? Type function. Type function is this. Apply type function is that. We have id type function, which is this. And so this is a string, and it's like type checks. Is there another, like a better way to see what this is? I think there should be a better way. Like when I'm covering this in the LSP, since this is an expression that I actually evaluate, I can know that so I know that the type of this is a type, right? But I also know the value, and the LSP can show it. Let's start with this. This is the simple example, right? What is that? And then we want the functors later. Okay. Oh well, okay. Maybe one of the things that we want to change though is if we go to generics, right? I don't want the type of ID to be 0 into 0, right? This is not correct way to show this. This is the normalized form. This is just the normalized form, right? This is just the normalized form, so I want to like swap these back into like that stuff. Okay. Yeah, that's like the only thing that I would want to change here. Let me just go take a bathroom break. All right, it took me 4 hours to do that stuff. But it's okay. It's because we were talking for 2 hours. So it only took me 2 hours. Can I implement this next part that will allow me to actually have higher kinetics today? I don't know. Oh, wait, hold on. I still need to fix this one thing. So let's fix it. How do I fix it? How do I fix it? Okay. Core syntax types. I want to have it. So in the interpreter, right? I say this evaluated with bindings, right? But I want to evaluate with the original bindings also, right? For printing. Does this mean that that's a separate thing? So this one is normalized and that one is not normalized. Yeah, maybe. So maybe we have evaluated with like with normalized bindings. I'll evaluate it with normalized bindings is a separate thing from evaluated with like the current bindings, you know, of the actual function that we use as a definition. So I evaluated twice just because of printing. Because otherwise, I mean, I could evaluate it once printing, but then like print should depend on the interpreter, and we have another cycle, which makes it very annoying. Okay, so we will have this, but I also will have with original bindings too. Okay, I want to have both of these. I want to have both of these. Okay. So with normalized bindings, it's going to be ignored when printing. Evaluate with original bindings, though, is what we care about. Right. There is no field evaluated with normalized bindings within type tuple. I hate OCaml. Why is it so bad? I renamed a field, and it renamed the field in another place. This is so bad. I hate it. The LSP is like renaming things that are not supposed to be renamed. It's probably like done in another place too. Evaluated with original bindings here too, with original bindings. What is this? Type tuple, because some of the like what is this? What is this? What is this? What is this? How did this appear here? Stupid OCaml. What is this file? This is inference simple. I need to like figure out what was there before because I didn't commit, because I was thinking that LSP will work properly, but it doesn't. Unite type generic. No, this one is correct. But this over here makes no sense. Why this was changed at all. Revert. Like, what is this? Like, look at what it did. So we literally had code. We literally had code tvariant which returns none, right? I did a refactor using LSP to rename a field in one place to this name, and now it just inserted this name over here, which makes no sense, right? This is none. I did not rename the option, a variant called none, into anything, right? Why? Okay, so now we have evaluated normalized A, evaluated normalized B, evaluated with original bindings, just valid original A, evaluated original B, function A evaluated with original bindings is evaluated original A, and we just ignore the B, right? We ignore this, we ignore that, right? Substitute bindings evaluated type generic, substitute bindings evaluated with normalized bindings, evaluated with original bindings, substitute type with normalized bindings, evaluated with original bindings is substitute type, state evaluated with original bindings. Okay, what is this now? Yeah, so this is I need to evaluate using original bindings. So I need to construct the thing with original bindings, right? Yeah. Type function. Evaluated with original bindings. Construct construct bindings argument. Let's see. Let's see. And so let's do this. Construct construct bindings argument implementation. This is going to have a function which takes as an argument the binding and index of the binding, and it should return a new binding, right? Like that. Yeah. Yeah. So this is going to be function get binding into this. So instead of okay. Construct bindings argument is going to be construct bindings args impl using function index binding, right? And construct bindings, construct normalized bindings argument is going to be we'll have index and binding, and I will just return this binding. And normalized binding is this one. This kind of expression is not allowed. Yeah. Okay, sure. Let's say span pattern value. Span pattern is this. Span pattern. Now that's allowed, right? The span pattern. Pattern binding. Yeah, this over here, this is pattern binding. And index in this case is already an int. Tuple result. What is this? No. Don't save. This should not have been changed. Revert. What is this? Evaluated with original bindings. I guess also can be ignored. This is yeah, this is doing the inference. Okay, that's fine. Tuple. This over here should just be called tuple. What is this? Value tuple. This tuple. Okay, success. Success means that we can go to generics. I'm going to, so right now this is saying 0 into 0, but now we're just going to evaluate this properly. And this is just going to say t into t again, right? Now this over here, this calls t and this calls t, but these are different t's, right? If I say this is x into x, right? Then this is going to be x into x, right? Even though this says t into t, we just keep one of the types. One of them is inferred from this definition, one of them is defined here. It can be any of them, right? I don't think I should normalize like when I show this, because I want to still see the original names probably. That makes sense, right? But now this is named like differently in two places, so which one do we actually use? Doesn't matter, I guess. Okay, so now this is now this should be committed, right? Allows specifying types of generics. All right, now to this thing. This basically means that I need to have a new kind of a type. So what can a type be? A type shape, right? This is all the types that we currently have in the language. And one of them is called binding. Binding is the variable which is like basically something that we don't know yet. So we can only know the type when we get into the evaluation scope where this binding actually has the name, right? This is a free variable. And this is like just a simple form. The more complex form can be that we have some form of an expression which requires us to wait for the evaluation, which has the variables with values already there, right? So I think instead of the binding, we should have. You have been struggling with your coding language development. What's your language? What are you struggling with? I'm not sure if I can help you because I am struggling myself, I guess. Unless it's something that I can help you with for some reason. But probably not. Because I'm bad at explaining things. Anyway. Have I seen your language? I don't remember. But yeah, basically we just have types which are expressions. And similar to that, we have values. We have also values. Value shape is also a thing which can have a binding, but now instead of bindings we have full-blown expressions, and so we are basically blocked by some variables which are free, which so this includes things like ft, where f is like the type function, which we don't know which type function it is, right? If f is let's just say type into type, then if we try to call function f with like t, then this is literally the type, right? We don't know the concrete function yet, and we must like leave it as is, as an expression, and we only evaluate it when we know this value. You're having trouble with getting mean and median functions working? Why do you need that for making a programming language? That's just part of the standard library of your language, I guess, right? Mean and median. Well, to calculate the means, you just need to add things together and then divide by the number of the things, right? And then to calculate the median, you need to sort everything and then get the middle element, or the average between the two middle elements. That's how you calculate those things, right? What's the problem? So yeah, and similarly to this is what's required for just hierarchy types. And I feel like if we store any expression, then we should be able to store any expression, including, for example, an expression like a plus b, right? So which will allow us to have full-blown dependent types, I think. I'm not sure though. Like if I have a function which is like concatenate two fixed sized arrays, right? So this is a function that takes the array of size A and array of size B, and this should return the array of size A plus B, right? Even if we don't know these sizes, these are not sizes that are known at compile time, we should still type check this. Which basically means that we should have expression as a value. Your parser keeps breaking for the min and median functions. I see. Just a parsing issue then. I feel like parser is like the easiest part of the language usually, though. You can figure it out, I believe. So yeah, basically, when I have the bindings, we should have like what do we call this? What do we call this? What do they call it in the dependently typed languages? Like in Idris. Like, for example, we have fx. No? F is do they call it int? Int? Couldn't parse any alternatives. Hold on. Neovim. Can I not do this in Idris? Like f is int into int. So f is this, but f is just f, right? So this is very similar. So f is a function which we know the type of, but we don't know the value of. It's a value without it's a binding, what I call it, or a free variable, a variable without a value. So when I call function f here using 1, 2, 3, then as you can see here, what is the value of me calling a function that we don't know the value of, right? That's literally what it is. So yeah, the value is the result of applying function f with argument 1, 2, 3. And we will only know this value once we know the value of f. What if I can I say something like can I say x is f1, 2, 3 and define name x? How do I define it in the REPL f1, 2, 3? Let's say x is int. I don't understand how to use the REPL here. Help. Evaluate expression, check the type. So it's not an expression, like a declaration or whatever, right? Is what we need in a REPL. Show times, search for a proof. Like, okay, I mean, I can just test it over here. If I say that x is equal to f1 to 3, right? Then we go back, and the type of x is an int32, but x itself is just f1 to 3, right? But can I now say that f is equal to x, fx is equal x, f z is equal z? Can I do that? Undefined name z. I don't understand how to write this language. Can I say over here that f z is z? Why can I do it here but not in the REPL? I don't get it. So f is now, and x is now this, right? So yeah, I define what f is after I try to call this, and like after this is known, now we know the value of x basically. Anyway, you're having a problem parsing commas. What's the problem with parsing commas? Salut, ty kapes dawno w ciemie. Salut. But we speak English here usually, if you can. Lionheart. Okay, so yeah, we need binding. So instead of bindings, I just have the general. I'm just wondering what to call it. Like, do I just call it expression? It's not an expression. It's like let's talk to ChatGPT here. So in a dependently typed language, are higher beings yet? Not yet, but I did do like the generic type so that I can specify the type of ID. And I mean, we have higher types, kind of, right? Let me show you what I did last time. This thing. We can say that the type function is like the function from type to type, right? It's a function that takes type as an argument, type t, and returns a type. And we can use it as an argument to another function, right? So this is a function apply, which applies function f with argument a and returns a type like this. So this works, right? And I can apply this function ID with a string, and this results in a string. What I cannot do is I cannot apply the higher kind of type where I don't know this thing yet, right? Which is required for doing functors and monads. So an independently typed language, I need to evaluate with 3 variables, right? What do I call a value which still has 3 variables? So we must evaluate under binders. We will inevitably end up with values which still have 3 variables. What do you call such a thing? Depending on tradition. Weak had normal form. Normal form, if you fully normalize everywhere. Yeah, like, do we normalize? Weak had normal form often includes the neutrals and lambdas. If it doesn't reduce at had, you are done. I have a feeling that I understand what it is. So like, it's not really like a normalized value, but it's only normalized at the head, right? That's what I was thinking about. Exactly, yes. So, which is like not fully normalized everywhere, but yeah. Weak had normal form. Let's search this up. Weak had normal form. An expression is in weak had normal form if it is either a constructor eventually applied to arguments like true, just, square, or colon 1, a built-in function applied to too few arguments, perhaps none, or a lambda abstraction. Know that the arguments do themselves have to... What? I don't know. That's probably not it. More semantically, open value, common in implementations and papers. Stuck value, informal but honest. Maybe when we call it stuck, like calling it stuck makes sense. Semantic value, closures plus neutrals living in an environment. The key conceptual split, canonical values, lambdas, constructors, literals, neutral values, elimination forms added by a variable. Most implementations literally define value is closure, constructor, or neutral. Neutral is variable or neutral app value or neutral projection. If you're doing NBE, and you should, neutrals are the reason the whole thing works. Neutral value elimination forms added by the variable. Go with name it neutral. What? Dependent types neutral. Check independent types with normalization by evaluation. A neutral expression is an expression that we're not yet able to reduce to a value. Okay, yeah. So this is what they call it, a neutral expression. It's an expression that we're not yet able to reduce to a value. Why do they call it neutral, though? Why do they call it neutral? So the only thing that I had before is a neutral variable. But now we have like neutral application, like, and stuff, right? So we basically have the entire language inside of the neutral thing. If we only want to have higher kind types, we can just say that we just have a neutral like application basically, right? Which is applying the function with the argument, where both of these are... Well, the function is neutral and argument is normal. Wait, argument is normal. What's a normal? Shouldn't the I mean, yeah, if the argument can be... Wait, what is a normal in this case? Normal forms. convert a normal value into the syntax that represents it. So normal values can contain neutral values inside them, right? Seems like this over here is a good tutorial. Never saw it before. Generating fresh names, freshen. Why do they call them neutral? Because they're neither winners nor losers in evaluation. They're just standing there menacingly and helpfully. In terms, it's called neutral because it's neutral with respect to computation. It's not a value that introduces structure, like lambda or constructor, and it's not a regex that can reduce. So it does not determine control flow. It's a computation, Switzerland. What does that mean even? Why this makes sense? Reduction only happens when the head of a term is something introductory. That makes sense. If a head is a variable, you're stuck. You cannot reduce it. You can pattern match it. You cannot look inside it. Yes. Maybe we can come up with a better name, which is less nerdy. What the thing actually is, it's computed as far as possible. It's blocked on missing information, waiting on a variable. Okay. Stuck. Residual. What does the residual mean? Remaining after the greater part quantity has gone. My actual recommendation blocked. But maybe we actually like what I'm wondering though is like, should these be like, should I introduce the whole language there, or should I just use the existing expressions? You know, that's the question. I feel like for proper dependent types, we will have to have the full language there. Let me take a look at my expressions. What are the expressions that we have? So like, for example, for higher kind of types, all I need is the instantiation of a generic, right? So this is instantiating of a generic. Instantiation of a generic contains the generic, which is an expression, and argument, which is an expression, right? But if we are storing this as a type, then basically it means that the argument is a type, but generic is like a variable, right? Which is the neutral value. So the argument is already like potentially evaluated. Right? Values and normalizations, normal forms. Neutral values. Following the recipe for normalization by evaluation, we need to define a value representation for each constructor. Down. Because, hold on, the value represent the interjection forms and type constructs because they do not contain implicit computation other than neutral expression. They represent only the values of Tartlet. What the hell is Tartlet? So they are not storing all of the language there. Then the neutral expressions is like different from the expressions. For some reason, why? Why? Because an expression variant can be evaluated to already a value variant, right? But the value itself might be like the thing. Expression function scope. Yeah, I don't know. Blocked. I don't like the name blocked. I don't like the name neutral. Wait, hold on. Blocked a variable spine, right? So it means that once this variable is known, then we can evaluate the spine, right? I mean, isn't that it? So we're blocked on the variable, and once this variable is known, we can evaluate this further, right? That's what the spine is here. Probably. So right now, the only kind of a thing that I can build blocked on is on the expression, which is just a variable. Right? Blocked. Blocked. Sure. Value blocked. Value blocked. And value blocked has the binding, and it should also have the expression that we need to evaluate once this binding is known. Is that not what I need to do? This expression is going to evaluate to this value, and right now this is blocked. Expression. Expression is not enough because, like, in order to evaluate thing, I also need to know the interpreter scope, right? Like, can I do it like this? So I need to have interpreter state here, right? State is interpreter state. So that once this binding is known, I can continue evaluating this. But how do I infer this then? This is weird. If I make this its own expression, like they do here, this is neutral application. So like there's the neutral application, and then there is just the application, right? So the language. So this is over here is the application. Eliminators. Or maybe like neutral is what we compile into in this language. Type normalization by evaluation. Reading back from values into syntax is accomplished from values into syntax. Yeah, that's like another thing, right? Because if I store the value as like its own language, right? then like what I want to show in when I hover, when I have a function like this, which has like array of A and array of B and returns array A plus B, right? So right now A plus B is just syntax sugar for calling the function, which is std operator add A and B, right? I want still to show A plus B. I don't want to show this in the LSP, right? I want to show the original syntax that was used to create this expression. But this one is actually like going to be called, and this over here is also going to be basically changed into like native add, native plus, you know, A and B. I mean, obviously I can have rules so that this is shown as A plus B. But that's a little weird. That's another question for the future, though. So I have value blocked. So now in order to do the type inference, I need to unify the blocked values. Previously, I only had the bindings themselves, and now I have like interval states and expressions here. This is too difficult, I think. So maybe I do need to have like a separate language here. So value blocked. Should this be value blocked binding and like value blocked instantiate, which is basically like I'm going to copy paste the language, right? So this is just going to be the generic that I'm instantiating. This must be the blocked one, right? But then the argument can be any value, right? This will allow me to do the hierarchy types. Maybe I just start with that, and then maybe I will. I don't know. I feel like it's weird to have like two representations of the language. You know, but sure, let's do that. Copy paste. Okay, so when I'm printing, now I need to like, now I don't have bindings, okay? Now if I print the blocked value, blocked, I need to print blocked value blocked. And print blocked value matter value unit for matter blocked value or value blocked. Let's call it blocked value. T match value with blocked value binding, and we print the binding. Block value instantiate generic argument. So in this case, I will need to, I don't even like, shouldn't I just say here, this should just be print binding, fmt binding, right? Blocked value, blocked value, blocked value. V expression. I don't have a V expression. Not exhaustive. That's not true. Okay, so I have wait, what? Okay, so I have a generic argument. So I'm just going to print that the generic is instantiated with the argument, right? So I just print blocked value generic, and then I print value argument, right? Like this. Okay, so when I'm doing the unification, and by the way, the same should be for types, right? It's not only the values. It's not the values, it's also the types. Type binding. So I don't have type binding. I should just have instead of this, I should just have a t blocked of blocked value, right? So the value must be a type though in this case, obviously, but that's the same. Okay, when I print t blocked, then we just print blocked value, blocked. Okay, now inference. Okay, this is the interesting part, right? So when the bindings, I was just, yeah, I just need to like unify the blocked values. T blocked A, T blocked B, then I say T blocked unite blocked value AB, and then T blocked and not blocked, and we fail, and unite blocked value is a blocked value function span AB, match AB with. So right now we just have blocked value binding A and blocked value binding B, which when AID is equal to BID, only then they are the same. So blocked value binding A. If we have a blocked value binding and blocked value and whatever else, then we fail. What is fail though in this case? Because fail, like I had the type error, but should I have the blocked value error now? But if it's a blocked value, then it's not really, it's an error that is not really blocked, right? Should I have blocked value error? the same problems in, like, we just return a here, but blocked value. A is not this. Print blocked value A, print blocked value B. Print blocked value is with cache. Print blocked value. Binding. Unite value shape. Type and binding. Binding and type. Interesting. A value blocked A, value blocked B, value blocked unite blocked value span A, B, value blocked fail B. So if we have a type and value is blocked, it means that the this means that the result of us blocking the value type unite type span T blocked B, right? That's what we want. T binding is none. This is infer value shape. So yeah, if I have the if I'm blocked, which means that I have not evaluated the type yet, then we don't do anything. Unite blocked value. Yeah, so now over here we have other things. We have a blocked value instantiate. Generic is generic A, and argument is argument A. And instantiate generic is generic B. Argument is argument B. In this case, we return instantiate, where generic is unite blocked value generic A, generic B, and argument is unite value argument A, argument B. If we have instantiate and this, then we just fail. Okay, that works. Now, what is this? This is type of value shape. So what is the type of a blocked thing? Now, that's the question. Yeah. If I have blocked B. Let's say type of blocked. Type of blocked is span blocked value type. If it's a binding, then we just return binding type. If it's instantiation, what is the type here though? Because if I instantiate this thing, what's the result? Well, I need to know the type of the thing that I'm instantiating, right? So we have generic and we have argument. So we say that generic should have type, right? So we say type of blocked generic. So this is generic type. And I need to basically like call this with this argument, right? The generic itself is blocked, but its type is not necessarily blocked, right? I just figured out my problem. It was an extra space in the Lexter when I generated the mean token type. Nice. Extra space in the Lexer. I don't think I remember having that problem. What do you mean? How can an extra space be a problem? What are you writing your language in? It means that your language's space is white space sensitive and an extra space results in a different meaning? Is that what's happened? Like in Python, if you like misalign your block? Generic type of block span. Wait, why do I need a span though? Span is fake. Span is fake. Span is fake. Type of block to be. You are developing in Python? Okay, so yeah, okay, that makes sense now. Yeah, that's why I don't like white space sensitive languages. Because like it's not always easy to see. I mean, sometimes it's not easy to see, and yeah, that's not really the reason, I guess. Hi, I saw a guy typing very smoothly in the VS Code. Do you know how to do that? What do you mean type very smoothly? VS Code smooth typing. Enable smooth typing and cursor animation in VS Code. Is that what you're meaning? There's cursor smooth current animation, true, cursor blinking face, cursor style under line, surrounding lines 15. Your lecturer was checking for us. Okay, so it was the space was inside of a string. Okay, that makes sense. Settings JSON. Okay, is this smooth now? I feel like this is not smooth. I'm not sure what you mean by smooth. True. Value is not accepted. Value strings are off, explicit or on. On. Smooth carrot animation. Is it smooth? Off? I don't know. Alright, anyway, so we're trying to instantiate a generic, and I'm trying to figure out what is the type of us instantiating a generic. This is, well, I mean, I guess this is very similar to blocked value. Okay, so I guess this is very similar. Yeah, it is very similar. It is very similar, indeed. It is indeed very similar. So blocked value, this is a blocked value shape, and then like blocked value blocked value is shape is blocked value shape, and type is type, right? So like similar to all of the other things, we have shapes and we have that thing. Okay. So print blocked value is having the blocked value, which is going to be, so this is going to be print blocked value shape, which is blocked value shape. Right. In this case, generic is a blocked value. Okay, so print blocked value now is the one that takes the value. So we have function fmt value into just print blocked value shape, fmt value shape, I guess. All right. So now in order to know the type of a blocked value, this is very similar then, right? Because all I need to do is I just say function, value into value type, because I store it inside now, right? Yeah. So when we have unite blocked value though, now we need to unite the types too inside. So this is going to be united blocked value shape, which is blocked value shape unite. Blocked value shape. Print blocked value shape. Blocked value shape. Print blocked value. Print blocked value shape. Print blocked value shape. Okay, and then unite. Unification for blocked values. Unite blocked value is span AB into the one where shape is unite blocked value shape, span A shape, B shape, and type is unite blocked value. It is just unite type, span A type, B type. Okay. All right, expect type. Expect type. If this is a blocked value now, blocked. So this is inferred span binding span. Type inferred span binding span. I don't have the span anymore, right? It's blocked. Do I have spans for these? Because these are expressions. I'm not sure. Type blocked. Blocked. Can I just say that this is span? I mean, yeah, let's just say over here, you know, let span be span fake expect type, I don't know. Inject binding. Binding. So we have add local. So the value is now a blocked value, which is blocked values are never inferred, right? Yeah, I don't think so. So we'll have a value blocked. This is going to be okay. This is going to be like shape is blocked value binding, and type is binding type, right? That's what the value of the binding is, right? Okay. Yeah. Substitute bindings. Okay, now this is the interesting part, right? So when I'm doing the substitution of the bindings in the interpreter, if I know that this is a blocked value, blocked, Now this needs to be like substitute blocked. Substitute blocked. This is going to return in a value, right? Blocked is turning into a value, right? Yeah. So we have blocked sub state blocked. This always gives me the value, right? Right. And I remove this. Blocked. And substitute blocked. State blocked. Blocked value. This returns a value always, right? That's going to be like substitute blocked shape. State blocked shape. I don't think that's possible. I think I need to like do it explicitly here. So I just match blocked shape here directly. And if it is blocked value binding, then I return all of this. What is original value though? If this is not found, this is the original value. So I need to have the original value here too, right? I need to have original value here too. Original value. So sub-blocked original value. In this case, I return original value. And if I have instantiate generic argument, then we are going to basically say, so in this case, right? So we have the instantiation of the generic and argument, right? What do you mean unused variable state? It's literally used here. Span. There's also span. Oh, span is from the context, right? So we have context and span is context span. Initialized, moved out, yeah. So when I instantiate, what do we do here? We say that that generic is substitute. So this one is blocked. So I substitute blocked. But what is the original value in this case, right? Because original value, so like, yeah, original value is the blocked one. Yeah. Do I need to have the original value here even? I'm not sure. So instantiate, this is not a, yeah, sure. Let's see. Let's just say original value is value inferred span. Span is context span. Inferred value blocked generic, I guess, right? Then I need to give it state and the blocked value, which is generic. So generic is now a value, and not a blocked value anymore, but it can still be a blocked one, right? It can still be a blocked one. But basically, we try to evaluate it directly here. And then we say argument is substitute value state argument, right? So in this case, we have a generic, we have argument, and what we need to do is we need to instantiate. But the problem is that now this is also recursive, right? Substitute bindings is its own module. So this needs to know how to evaluate, basically. Doesn't mean that my context, maybe my context should know how to evaluate. So that I like break the dependency cycle this way. Context has like the interpreter which knows how to evaluate. This is the interpreter core. Interpreter core itself depends on substitution. Substitute bindings. Hello, Brainoid. We have like we are calling into this from inside of the interpreter. So I'm going to give this maybe I'm going to Interesting. Like I'm already given it the interpreter state. How have we been? Well, Nerdsoul is also releasing his game on Steam before me, I guess. How have you been? We're probably going to work on Linkstar next year, though, in the beginning of the year. So soon. How's your game doing? Pum 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 pum. 3,000 sales in 29 days. So it's like $3 billion or something, right? That's good. That's good. Yeah, and it's like I'm once again in this problem where my language is too recursive. How do they like write these other dependently typed languages? Like it's literally recursive. Do they write everything in one file when they implement this? There's no way, right? They do that. What is Idris written in? Idris. So, Idris Lang. Where's the source code? GitHub. It's written in, it's written in Idris, obviously, now, right? I'm just like wondering if does Idris allow for like recursive things, or are they breaking the recursion somehow in the language? Because like type inference can invoke evaluation, and like all of this stuff is just highly recursive. Source core. Like, what is this all basically a single compilation unit? Like we have normalization, for example, right? Evaluation. So we have like evaluate or whatever, and you can so you are importing core other things, right? So this is depending on core end. Like, can these imports be recursive? Is this similar to Rust module system, or is it similar to your other module systems. Like core value, right? Core value. Core primitives. Context log, case tree. Core normalize eval. That's this module. Can modules be have cyclic dependencies in Idris? Because like there is no way they can do it without no. Idris does not allow cyclic dependencies. Longer but blunt. Idris builds modules in a dependency graph that must be acyclic. A imports B and B imports A. The compiler will layer at you and refuse. Mutual recursion across modules is simply not a thing. What you can do instead, you can refactor shared stuff in a third module that both modules import. Use interfaces, records, parameters to break the dependency. Inline or duplicate, reorganize to the dependency arrow points only one way. So if my stuff is highly recursive, I must write everything in one file. Recursion is not the problem. Cyclic module dependencies are. Those are different beasts. You can have insanely recursive functions, mutually recursive types. Proofs that ate themselves for breakfast. All of that is fine inside of a module. One module owns the core part, so that's why we have like the types module right now. Yeah. And we have eval, which imports the types. Yeah, but let's say we have modules eval and inference, and since the language is well, I mean, I guess it's inference that depends on evaluation. It's not like because evaluation does not depend on the inference, right? It's inference that depends on evaluation technically, but I have them the other way around right now. Or do I not? And I mean evaluation might do something here. That not is real. You're not imagining it. That does not mean one file forever. It means you have to deliberate about where the knot lives. Evaluation and inference are mutually recursive as processes, but they do not need to be mutually recursive as modules. The mode that actually works, put the knot in one place. You create a core module where the mutual recursion lives. Judgment. Inside we have infer and eval. Mutually recursive, mutual block, totally legit. But this means that all of these things is in one file, right? Split views, not logic. Judgments. I don't get this. So if eval is in judgments, how and so is eval in judgments and not in eval module. Eval is not where the evaluator is defined. But if eval is not where eval is defined, then everything is in one file, judgments. Only the mutually recursive core must be in the one module. Well, seems like my core is the entire thing, which is a billion lines of code. I don't understand. So they have the eval here, for example, right? Eval. There's the big match on what we are evaluating. Apply to stack and eval. Well, I guess this is the eval, right? So we are evaluating. This is like some context, some prefers. So the actual arguments are the env and the local env. So this is the term. So we're trying to evaluate the term stack free, whatever that means. So this is what we're evaluating. We're evaluating a local, a reference, an application. No, yeah, the reference, a meta, bind lambda, bind let. So this is application of a function, whatever, right? Yeah, okay, sure. Whatever. But what do I do? What do I do? So in like substitution, do they even have like substitution or whatever? Do they call it substitution? They have substitute, whatever that means. I am new. Where are you from and what are you making? I'm making my own programming language. Just from right here. Yeah, I'm trying to make a programming language and I'm working on figuring out how to make at least the higher kind of types work. If you know what that is. All right. So I can either pass this as an argument explicitly, which is going to be very annoying. You know what I can do? Oh, that's what I can do. Hold on. This is going to be ugly though. Here's the idea. Here's the idea. So like I just need to be able to call, like in this case, instantiate, right? Instantiate is the function which performs the evaluation. I already have the state there. This is the generic value. This is the argument. I already have the spend there too, right? All I need to is to be able to call this function from inside of the other module without introducing the dependency cycle. So what we're going to do, we're going to say over here, let instantiate. Okay, let's do this. Module interpreter instantiate is ref none. So this is going to be a reference to optional to the function which does the instantiation. And instantiation is a function that takes span, takes the interpreter state, and then takes the generic, which is a value, and the argument, which is a value, and returns a new value, right? So we start with none, and then inside of the interpreter, it's so bad. Can I say here, can I just do this? Can I just do this? Let unit is like substitute bindings impl dot interpreter dot instantiate is some instantiate. I think I can do that. So when we instantiate, we are just going to say that instantiate is interpreter instantiate. So we take this and then we do option get, and then we just instantiate span state generic arc. Okay, yes, that's good. That's so ugly. I like it. All right. Okay, so now if we have a type which is blocked, then what we're going to do is we're going to say that value is substitute blocked. Original value is value locked value in third span. So we substitute this state blocked and then we just return value expect type, and we match value expect type with, and now I have this thing. And this can be removed. Then this logic is already duplicated. Unbound value span. Wait, I don't have the span here. Span is context span or whatever. Sure. Okay, interpreter now. Construct binding arg impl. Oh my god. So this is going to be, if I have a pattern binding value, maybe I can have like value binding, span binding. How about that? Binding, span binding is value blocked where binding, where value blocked, shape is blocked value, binding, type is binding, type, inferred span. Yeah, how about that? The type instantiate has type span state. Okay, so that one is having span as unnamed argument apparently. We just do that. Sure. Okay, core syntax. Okay, what is this? This is a binding. So when I have a binding, if we have a value which is a binding, what is this? Binding, binding var inferred opt. Binding, binding, binding. Place expression binding. Inference var inferred opt with some. I guess I need to have like this over here is basically now value blocked, where shape is blocked value binding, type is whatever in this case, I suppose. Then we just do that. Okay. BV binding. Do I have BV binding in like over here? Yeah, V blocked, V inferred. I feel like this over here should just be like value binding, span binding, span binding instead of this. That simplifies stuff a little bit. So, and now I'm already at the LSB. Okay, nice. Type blocked. Type blocked. A variable, compiler scope, type parameter. I don't know. This is just an icon. It doesn't matter. Okay, it compiles. If it compiles, does it work? Let's take a look. Generics. No, monad. Can I do a monad? I mean, I cannot do a monad. This is going to be still the same error because now I need this to be, because I never construct, right? I never construct the blocked value instantiation, which is required over here. Okay. So which means that if I do instantiate, right? What's this error, right? I expected a generic. Expected generic. This is literally when I instantiate. So when I instantiate, and I know that the value here is blocked, if I know that the value here is blocked, if I know that value is blocked, that's the generic that I'm trying to instantiate, right? So I'm trying to instantiate the generic with an argument, but if the generic itself is the blocked thing, right? Then what I return is I return value which is itself blocked, where shape is blocked value instantiate, generic, argument is argument, yes. And then the type, what is the type here? And the type is, What is the result type of the instantiation? And this is a gen. Wait, hold on. Yeah, what is the type here? What is the type? That's the question. In order to know the type, I mean, I know what is, when I do the instantiation, I know what my result type is, right? Though I know what my result type is. Result type. Why am I having this? I don't know. So result type is type. So type is result type. Shape is block instantiate. Instantiate. So when I evaluate this, I know that a result type is. Well, I mean, should this also be then substituted? That's like weird here. Well, I mean, let's just see right now expression data type, right? So we have already inferred the type that should be returned here when I evaluate that. And we can just use it. Instantiate. So this means that we have a result type here too. And so the result type is my original blocked type, right? Blocked type. I already know it here too. So when I instantiate here, value generic, this is cast result type, the result of me. The result type here must be type, right? So result type. Result type is, what is the type here? Wait, hold on. What's the result of the instantiation? Value generic. What do I instantiate here? Target. There should always be a type though, right? Inferred span. So that's right. Okay, let's see what happens now. Monad, restart language server. Okay, hold on a second. Fmap. Hold on. So let's do this. Fmap. Functor. Let's do just type here so that I can see it. Like lat underscore, which. So I have a functor. Wait, what? No. What do I want here? Functor itself, is this a type? No. This over here, is that type? It's not complaining, which is weird. Doesn't mean that it works. How do we do this? So we have a functor. I feel like this is not allowing me to hover here. Fmap. This is a type. I just need to I just need to Fmap itself is a type. Because that's the field of this. I mean, yeah, that makes sense. I want to know what this is, though. How do I print it? How do I print that? How do I print that? Maybe we do something like this. Who is f into, let's see, so f here is like unknown, right? But if I say functor f, so this now says that f, because I used it to use it inside of a functor, this is now the type like this, functor f. Now I want to say like let underscore be functor f is underscore, right? Let's do this, and then underscore. Okay, there you go. There you go. Okay. So this, so now, yeah, I think this works. I think this works. Okay, so how do we use the functor? Hold on. If we have a functor, how do we use it? Functor. Haskell. How do I test this, that it works? So if we have fmap like this, right? So we just related functions. Create a new fb from fa by replacing all of the values in fa by the given value of type b. fab. Yeah, we replace all of the things by b. Okay, let's do this. Sure, const replace all. So we have replace all, right? This is a function that takes, so we have a functor. This thing takes the functor. How do I call this thing though? Like, let's say a is ft, right? So this is ft, a ft, and like b of type b, or like let's call this a, and this should return well, I mean, I need to know the instance here, right? Because if this is a thing, so I need to basically know f as functor, right? Dot fmap. We have a and we have b. All right, so we just fmap a by having a function that ignores the input and returns b. Blocked value shape f is not equal to f. Wait, what? Why is f not equal to f though? That makes no sense, right? That makes no sense. F is not equal to f, but f is obviously equal to f, right? I mean, why would f not be equal to f? Maybe these are two different f's. Let's rename this one to f2, and then see here, and then it says f is not equal to f2 because I have not substituted the binding somewhere, right? Yeah, so the type of a is f type a. This over here is underscore. Well, I mean, this underscore is of type a though, right? This returns b. I mean, this is not inferred because, I mean, because that was not, right? It's supposed to be inferred here anyway. So what's the problem? Blocked value shape. F is not equal to f2 because the type of this as functor is this. So yeah, this over here keeps f still being there, right? Okay. Hold on. If I have like trait is self, you know, foo self into self, right? And if I say something like int32 as straight, what is the type here? This is type or whatever, right? So this has type int32 into int32. So like this was substituted properly. Okay. So what was not substituted like is over here. This still says f. Why? Because this one is a generic. Okay. So this is a type which is generic. Okay. I understand. I know. So substitute bindings when I have type generic. When I have type generic, evaluated with original bindings, right? I have this. Well, I am substituting it here though, right? But this is evaluated with original bindings, right? This is not. Well, I mean, yeah, no, that's fine. That's fine. So we substitute the type. Inside of that type, okay, we have trait where this is a functor or like whatever. F is type function, right? Which is just that. So this should return foo, which is of type f int32, for example. That's what I want. Expected a type got error. Why? Wait, why does that return an error? Expected generic. Wait, what? Why? Wait, hold on. Can I do t, f, t? So this works. The other one did not work though, which is weird. So this is going to be of type foo, which is tft, right? And as you can see, this is ft. Although, yeah, so f was not substituted with an int32 here. Int32 is obviously not a type function. I guess this would be like better as option t then, right? Because that's the type function. But this should be like option t basically, right? So it's not substituted. And then there was this other thing where we say like a is like f int 32. Wait, this works now. Wait, what? Okay, so as you can see over here, f was actually replaced with an option. So int32 is an optional int32. Oh yeah. I guess this makes sense why this was an error, because I was saying that this is an integer. Yeah, but this other one, because this one is generic, it's not substituted properly. So why not? It means that I need to like. That makes no sense. Oh, it's because I'm creating a new. Wait, no. What? Why? What? Huh? Well, these are the original bindings, right? F is the original binding. I feel like this should work, right? Because all we need to do is we need to like, we have evaluated with the original bindings, and I'm just substituting that. Right? So, oh wait, is it because, hold on, we have, wait, no way. So, evaluated with original bindings is an expression which is f t, right? which is a blocked expression, which is blocked on F. Which is a blocked expression, which is blocked on F, which this is instantiation. So I substitute this. Wait, what was my context? My context is sub, span, and depth. Okay. State is not there. Instantiate. I don't see how this is different though, at all. Why is one of them substituted and the other one not? This one is a generic type, right? Let's just say over here, let's just say underscore as trait. What's going to happen then, right? So this is underscore. Wait, what? Why is this underscore though? If this is underscore, this is... yeah, because we're waiting for this to be inferred, I guess. So, yeah, that makes sense, I guess. It's not inferred. It's a different type, not this one. Can I like? How about this? How about this? We have let's do this. Let result be type result. Can I do that? Can I do that? That's like the same thing, right? I just want to comp time dbgprint result. I want to know what the type is here, because okay, yeah, and this is going to print to the std out maybe. Examples monad. Like, is it going to print it at compile time actually? It says that it's result. Okay, I mean result is a runtime. Yeah, we need this to be like a const in this case. Right? Does this even work? Okay, yes. So as you can see, the type here is f int32 and tft. That makes sense. So this is a generic type, and we're going to substitute that. Let's remove the printing, because that breaks the LSP, I guess. Oh, wait a second. Look at this. I changed this into a const. And now this is not being substituted. Why? So the difference is that this is evaluated immediately instead of every time I instantiate that. So let and const here behave differently. And this is still an f and it's not an option anymore. Okay, that means something, right? Okay. Okay. I think it has something to do with like... It has something to do with something. So I have like different substitution modes, right? And let's see, when I interpreter core instantiate is doing the substitution, right? I mean, substitution is called, and over here call of type function, right? colon typed function, substitute mode, function only. Okay, that is not right. Okay, I see. But why was it this function only? Because this was a hack. I'm actually not substituting the types and only the function types. Why? Can I do full here? This is going to lead to some error though, right? This was done on purpose for some reason. Yeah. It's just something that we went too deep because we have like too deep recursion now when substituting. I want to like substitute what? Full. So this was function only. What else do we have? We have a type only, function only, and that. Do I do type only? I do type only over here when I'm instantiating generics. This is where I'm doing the types. How do I like... yeah. So like what I need in this case, I need to substitute the type, but like... When do I stop substituting so that I don't have infinite recursion is the question. A function only definitely was a hack. Type only... Is this even being used anywhere? Oh, so like this is literally, so when I call the function, this is when we use it, right? So when I call a function, normally like I would ideally want to substitute the things fully, right? But if we have a function only, then we only do this if this is a function. And we have type only. Value in first one, type, expect type. I mean, yeah, so if it's type only, then we expect this to be evaluated to a type and then we substitute it. Which is only is doing that in the type inference. Function only is the hack. Maybe I need a different hack. Maybe I need to like substitute stuff if it's not function only. Let me just see. Bum, 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 bum. So because because I was like relying on this evaluating, I see, and this over here is a constant. So the reason I cannot do full substitution is because we have infinite recursion when we have recursive types, right? When I have a type, recursive, T type, inner, recursive, T, right? I mean, yeah, I think this only is a problem with generics. If I do like that. So recursive, type, when we instantiate this, we want to replace all of the occurrences of t in this expression to be equal to the actual value of t that we use to instantiate the generic. Right? So I need that for functions because they are compiled, and this is function. Okay, I feel like function only should be low. Like, should this be? Yeah, the problem is that like I have functions inside of my type, right? Type only. I feel like I'm so close. I'm so close. I almost have the HKTs. Okay, hold on. Hold on. I need to have a hack of sorts. I need to come up with a hack. I think. For now. Or maybe we need to think about the substitution and how to do it properly without the hacks. Okay, so once again, the problem is that we have recursive types. We have recursive types, right? So what is the type of a recursive int32, right? Well, easy. It's this thing where we replace every t with the recursive, where we replace each t with an int32, right? So when we evaluate this, so we first need to evaluate this and then replace all of the t's with that, right? So how do we evaluate this? Well, in order to evaluate this, we need to evaluate recursive t, where t is int32. And then we need to substitute all t's with int32s. Again, recursively, right? But we know that we call the same function with the same argument, basically, so we can use the previous result, right? But what is my previous result? We did not calculate it yet. We did not calculate it yet. Well, I mean, the real problem is that, right? So like this over here in this case, so the recursive int32, this is basically this. This is, let's call this R. Let's call this R, right? And this is just going to be like, let's just say that this, RT, right? So how do we do this? How do we do this? How do we stop the infinite recursion here? We say that let's say x, Rx. What is Rx? Rx is basically, we take the definition here, right, which is which is rt, we are calling this function, we're evaluating this. We know what that t is x, right? But then I need to say that Rx is Rx with t replaced with x, right? Now we see that this does not contain the t's, right? But the my language is not aware of that, right? So it's trying to evaluate this and substitute this with t equals x, right? So the way we do that is that when I substitute that, I say that first that Rx is like a variable, like we initialize a new not inferred variable, right? Rx. So this means that this is also Rx, right? With t equal x. So this is doing the substitution of the unknown variable, right? This is we first initialize this to unknown variable, and then we try to do this. So since this is variable, which is unknown, because we can only evaluate this, we initialize this to unknown variable, and now I want to substitute the unknown variable, and I want to substitute the t's there with x's. So because this is unknown, we basically say that this is Rx like replaced, you know? Rx replaced is this, right? So we initialize this to the variable, and now we pretend that it's already evaluated. So we're saying that Rx is equal to this Rx replaced, right? Which means that Rx is equal to this new variable, right? So this variable is now equal to this variable, and now since this was inferred to be equal to this, now we are trying to substitute this, because like we are trying to make progress here. This was inferred to be equal to that, so we're trying to continue the progress. And now, so now we want to know basically what is Rx underscore with t is x. We don't know what Rx is. So we create a new variable called Rx underscore underscore. And then this happens recursively forever, and we like do infinite loop, and we use infinite amount of RAM. That's the problem. So how do we stop properly here? I need to stop when we know for a fact that nothing needs to be substituted. How? Well, I mean, actually, I already had the solution for this, but when I had the solution for this, that's literally when I dropped, because I need to like maintain this scope in which the variables can appear in the inference variable. And then whenever we are substituting, we're basically exiting the scope. So this is a process that cannot happen infinitely for sure. But that requires, once again, cyclic stuff is required, right? So because now for each inference variable, I need to maintain the scope in which this inference variable exists. And then when I unify variables, and when I substitute, I need to always go up the scope. So when I substitute, I basically want, I don't know. There was some problem with this. Is there another solution? Is there another solution? like I cannot just say that if we go too deep, then we stop, right? I don't really know about functional programming, but what the use cases are there for this kind of recursive type? This is just a simple example. Normally the recursive type that was causing the infinite recursion is like literally just the just a regular tree, right? So for your data structures like maps and sets and whatever, right? You use a tree, which is a node which has like a left and right subtree, for example. Right? This is a binary search tree. Whatever. This is a trip, for example, and this is a recursive data type. And yeah, the recursive data types are a problem for substitution. The example that I was working is simplified, yes, but recursive data types are useful in general, right? Obviously. But the problem is that they are causing infinite recursion when type checking for me right now, which is obviously wrong, right? And specifically, it's not just recursive types, it's recursive generic types, right? Because like the way this works is basically a generic type is basically a function which takes an argument, which is a type, and then returns a new type, right? So the way I'm doing this right now is I'm literally just evaluating this, right? I'm literally just evaluating this. But we obviously cannot evaluate recursively. So it's like functions, which if we call them multiple times with the same argument, they should always have the same result. So whenever I'm calling the function, so whenever I'm instantiating the generic, I first, before evaluating this, I say that I create a new variable, a new inference variable, which we remember, and say that when we next call this generic with the same argument, it's going to be like the same result, right? Then we evaluate, and then we actually like unify the result of the evaluation here and like the variable, you know, which is how we break the recursion of evaluation. But then there is also the process called substitution. Now the question is, why do we need substitution? Well, that's because, yeah, why is that? Let's think about that. Why is that? Well, that's because this is a function that is compiled only once, right? So specifically in the example where we have a type which like, so this is a type which has a field, like, I don't know, field X of type T, right? So this is a type expression. I can evaluate this. If T is known, then we are going to evaluate this properly, right? But the problem is that when I evaluate this at compile time, right? Evaluate this at compile time, which means that this is a function that's returning a constant in which has T inside of itself. It's a little bit weird, but we do this because if a function itself is a generic function, then I only compile the function once, and the type inference basically is a constant which is evaluated at compile time only once when I compile the function, right? And the type inference basically can have these generic arguments inside of it, right? So it's basically the same as evaluating this thing at compile time. So over here we say const result, right? And then we return that. So this is the constant which contains the variable which was not available at compile time yet, right? So I was evaluating something with a variable which is not known yet. So when I call this function for real, I need to like substitute the values which did not have values with the values which have values now. It's weird. But that's what we do. I'm actually wondering. Wait. Actually wondering. What if I evaluate those at... Hold on. What if I use the full substitution after all? So function only is used over here. Let's just say full here, full substitution, right? So this is going to have the problem of 2D recursion. Over here, when I'm including the map, when I'm evaluating this, right? So I'm trying to evaluate this. This is the generic type. I'm trying to evaluate this, and we go into the infinite recursion because of the substitution and stuff. So what if I say over here, I want to say comp time here. Isn't that the same thing anyway? Is that going to fix it or not? Well, now it says blocked value shape t is not equal to t. Well, because now the substitution works incorrectly or whatever, right? Data t type. Hold on a second. That's the problem. So it's because this t2 is now t2, right? And now t2 is not equal to t, right? So now t is not being substituted. Wait, why is it not being substituted right now? I need to restart the language server, right? Oh. Wait a second. No, but now it does not infer this stuff. Hold on. What's happening now? Still it's crashing. Why? Trip. Oh, we still went too deep. Yeah, I guess it does not help. I think this doesn't matter. I think this doesn't matter. Well, I mean, what we are doing is we're trying to instantiate the generic, which means calling this function and then substituting, right? And when I'm calling that with the same one, I know that. So yeah, I need to maintain in the value that it was already substituted, basically. I already had that idea. Why did I not make that? So the first time we substitute, we know that there is nothing to substitute anymore, basically. All right. Let me see. So maybe I can come up with something. So I'm calling untyped function. This is instantiation of the generics, right? So I am calling the function, which is the generic body. I need to substitute this fully, but I need to not substitute it if the result here is a variable, which is already which has been substituted already. So once again, we say that yeah, I save the placeholder, so I say that this is new not inferred value, but the problem is that this new not inferred value is trying to be substituted later, but it should not be the case. So like this value should know that nothing there is nothing to substitute. What does this mean? But there is only nothing to substitute if I do this. If I try to instantiate the same generic with the same argument, not with another argument, right? So we have this like instantiated generics map. Instantiate. What do I know? So like, I feel like substitution mode should have something. Should have something. Like, when I'm doing the substitution, I don't know. While I'm performing the substitution, I don't understand this. This is the most confusing part of the of this stuff. Again, let's try to explain this from scratch then. So the problem is that I have the recursive type TRT, right? And this thing is the recursive, right? Okay, so let's say that let underscore be R int 32. What's the type of this? The type of this is underscore. I mean, this kind of makes sense, right? Can I say like dot inner is RT? So this is literally recursive type. But it's like 2:49 a.m. Yeah. Don't worry about it. Place is not initialized. Inner not found. Type. Wait, what? What are they talking about? Wait a second. Is this also infinitely recursing? Cast examples. This is hello. Yes. Oh, look at this. We have infinite recursion already. Like even in this problem. I mean, yeah. Does it mean that I am also growing my memory right now, like crazy? Oh no, my free memory is going down. Look at this. My cast is using 7 gigabytes of RAM. Shit! Abort! 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 pkill cast. Don't eat my memory, please. Alright, we're safe. All right, so here's another bug I guess. Oh, wait, I know why this is a bug, because I'm trying to, yeah, because this is a constant and I know this type shape, so I'm like actually doing that. Yeah. Let's instead do reference here. I think if I do a reference here, it's going to work. Yeah, there we go. That works because that means in direction and I will not infer this thing. Okay, so there we go. So this over here is a recursive type, right? So this is a type, this is its ID, and this just recurses into itself. This is correct, right? This is correct, but that works right now because I don't have that stuff. Can I remove everything from the standard library though? That's the lib. Let's remove everything else that has a recursion, like I guess collections. I'm just going to remove collections altogether. And then I don't do that either, right? Then we can try to unlock this and say full. And it's probably going to at least drop me into the REPL. Yeah, so I'm getting to the REPL, which means that I can do cast examples hello. Wait. This still works. Wait, why does this work? Okay, what's the problem? Okay, but this is not working correctly though. This is inferred as something else. Oh, because this is a reference and inner is a reference. Hello, namer. Hi. This is inferred still, but it's inferred incorrectly, which is interesting. Let's call this A. And let's call the B here. But if I have two recursive types, A and B, so B is going to contain A and A is going to contain B. Does that work? Am I eating the RAM now? Not yet. Not yet. I'll keep this open. So this doesn't work. It says went too deep, right? So now we are too deep in recursion. So does it work with mutual recursive types only? Yeah, probably with mutual recursive types. Right? Because, yeah, how about... I feel like we can go without references, but just do that. But I want to like dbg print a int 32. Stupid below. What? I blame Nigel. Wait, is the bot? Did the bot stop working though? Why did it stop? It says that it's running. It just it stopped. Bot. I don't know. It just stopped receiving messages from Twitch or something. Just like my previous bot in Rust, right? It's the same mystery. Well, now it's exited. Oh, wait, hold on. Now it exited. Hold on, what's happening? Oh wait, it cannot. Yeah, it cannot read the bytes. Okay, no, never mind. I think it cannot connect. Right? Because it says that 0 bytes were read. Like, I'm refreshing my stuff too, right? Maybe this does not work. Access token, like, yeah, access token is still the old one, right? Wait a second. Is it not refreshing the tokens properly? I think my access token, like, yeah, and now it is actually refreshed. So, which means that the bot is about to reappear, I think. But why does it work when I do it manually? If this is working on every... Yeah, see, bot joins the chat. But like, this is literally what we do every time we try to run the service, right? Well, first thing that I do is I'm trying to run this script. So why does it not work? That makes no sense. So once again, this is my service. It just runs this thing. This thing is a bash script. And the first line is just calling that. And in the working directory, home CoolieBot, which is literally what I just did manually. Wrong bash exec. I don't know, like I literally just did this manually and it worked. I mean, I used my actual bash, I guess. Permission denied. Chmod plus X missing. Oh, when you wait, chmod plus X on what? On this file, refresh sh. Oh, and that's why. Okay, wait, but why does it work with normal bash? So bash interactive and bash is different thing. It's like bash works, but bash interactive doesn't. What? Is this bash different bash? Hold on. Oh, yeah, wait, hold on. This is a directory. Wait, what? It's because this is a directory, which is the package which contains the bash. Oh, shit, I understand now. Okay, that's my bad then. Why? That's my bad. Okay, we can go to... projects could be bought. Right, so we have the flake, where my app. Yeah, so yeah, we don't do packages bash because that's not executable. We need to do bin bash. right? But also, I guess maybe like stat minus e here would help, probably, right? Also, was that not present in the logs? Was that not present in the logs, or maybe I just didn't see it? Yeah, like it's not in the logs. The bash should say that it's not executable or whatever, but it wasn't saying that. Fix executing bash correctly. All right, now it's going to be actually fixed, right? For sure. For sure. All right, now we're back to this hell of the problem, which is I am doing inference here, and it is doing it forever. We have infinite recursion with mutually recursive generic types. Why? Why? Wait, can I just say that this is like BT and this is like AT, just so that it's like even easier? Because no, this is underscore. Okay, what if I say type? BT. Now we know that it's a type, I guess. What if I say type? Okay, so we say type field is that. Now we have infinite recursion. Okay. At least somewhat simpler. Went too deep while evaluating this thing, right? Because I was substituting the bindings here all the time. Okay, so how do we do this? So first we say that I'm trying to evaluate a int 32. I'm trying to evaluate this. So I'm saying that this is equal to like let's say that this is variable a, right? So I'm trying to evaluate this, which requires evaluating bt, which requires evaluating bt where t is int 32. So we're trying to evaluate b int 32. Let's just say that this is equal to b, right? In order to evaluate this, I need to evaluate a int 32, which is already evaluated to a, right? So we know that this is equal to a. So we say, okay, this is evaluated. Let's go back. This over here is b. Well, I mean, we know that we wanted to calculate a int 32, which is just a basically, and now we want to replace all occurrences of t with int 32. So I need to substitute. Well, I mean, it's in the process of the evaluating, but the first thing that we do when we evaluate this is we create a new inference variable so that we don't do infinite recursion specifically, right? But now that we know this, we need to substitute. We need to substitute, like if a is a variable, right? If this contains t's, then we need to substitute t with int 32, right? How does this work? Well, we say that this is going to be initialized, so that we're trying to break recursion. We initialize this to like a underscore, right? And we can only continue substituting when a underscore is known what it is, right? Okay, so now we basically have evaluated this. So b is equal, so now we say that b is equal to a underscore. So these two are the same variables now, right? And since this has been evaluated properly, we now know that a, so now we go back to evaluating a. This contains bt. We know that it is a underscore, but now we want basically a underscore, and we want to substitute that, right? Because that's bt. Bt is a underscore, and we need to substitute, in this case, all t's with int32s. Maybe this helps. I don't know, what is this? What does it help with? What are you trying to? Helps with what? Run. Hover over B. So okay, sure. What are you trying to say? That's what we should evaluate. But I mean, this is also generic. AT, BT, A, BT, right? And AT. That's like the thing. Yeah, but this is what we should infer it to be. Yes. We should infer it similarly to this. Okay, anyway, let's see here. So we're trying to substitute the a underscore with t, right? A underscore. We don't know what it is yet, right? So we assign a new variable here, a underscore underscore. Right? Okay, and then we say, basically, that now we know what a is, because we finished evaluating this. So we know now that a is equal to field, which is a underscore underscore, right? Okay. But since we know what a is now, we can actually perform the substitution. So we are going back to this because this is now inferred. We know that this is a tuple, right? So we're trying to substitute. So what we are seeing that this tuple contains a underscore underscore, and we are continuing this because we are now, instead of substituting a, we're substituting this thing because we know that a is now equal to this. So how do we do this? Now we are trying to do this, right? And because we're trying to do this, we are basically trying, as part of this, to substitute a underscore underscore, and we're trying to substitute t with int32 here, which results in us having the new variable, which a underscore underscore underscore, and we go this way infinitely. So how do we break this? Infinite chain of recursion. Why like we basically so the thing here is that we know that a underscore underscore we know that a underscore underscore or I mean yeah so like b, which is a underscore substituted with that, right? Like this is a underscore underscore underscore. This is this thing. We know that this thing has already been substituted, so I need to like never substitute it, but I need to never substitute it only in this scope, in the same position, if that makes sense. But I don't have the position, or do I have the position? I mean, I guess I kind of have the position, right? I guess I kind of have the position actually. Okay, I have a weird thing that I can do. So my inference base over here. Here is my inference variable right now. Yeah, I feel like inference variable should know it was substituted in certain places or something. So I need to have a set of places in which it was substituted. I think. You know? And we can keep IDs of that. And then every scope has an ID. Right? And that's how I break recursion. That's probably going to be like the easy way. Like substituted in is going to be like a set. It must be a set because we're going like mutual recursions. We're actually performing the substitution in two places recursively, right? So this is going to be like hash table. I mean, not a hash set. ID set or whatever. ID set. How do I like say that now? Maybe I make this mutable too. ID set. Let's create ID set. Module set is set make t. When we create this, we say subbed in is set empty. ID set empty. Subbed in is ID set empty. Print subbed in, we ignore that. When we unite, subbed in is subbed in A, and subbed in is subbed in B. So when we are uniting the variables, we're just going to unite these sets. So this is ID set union, subbed in A, subbed in B. Okay. And now I want to expose the function, which is, you know, well, is, I don't know, like, I want to say that this is subbed, right? Subbed. Remember, remember subbed is going to be, so if I have a variable, and I have the ID, then we remember that this variable is substituted in this ID, right? Sure. Sure, let's remember subbed ID variable unit is function ID variable into, so we should say root is find root var in root subbed in is root subbed in ID set add ID, right? Just like this. So just mutate it like so. Okay. All right. So now we do substitute bindings. So we have state, right? And the only thing about the state that I actually care about here is the scope, right? Is the scope. Do I do type only and function only? I feel like I only should either say none or full. None is just for performance reasons on the interpreter, and full is full. Sure. So I should see sub var. This is the important thing. So we have the variable. And we are substituting it. And we have the state somewhere here, right? State, interpreter state has the interpreter scope, and interpreter scope has ID. Yes, that's good. So we just say that if yeah. So we always return original value here if this was already done in this scope, right? So if var well, I need now in my inference and to say like was subbed in, right, like that. That was subbed in. So it's going to be function ID var, and this is like root is find root var, and then I say root sub in ID set can find. What am I trying? Like how do I say contains in exists? Not exists. I mean, like find, I guess, find opt member. Oh, member. Okay, yeah. So if is this a member of this set, right? MMID. Okay. All right. So I say if var inference var was subbed in scope ID. So I say that scope ID is state scope ID then, right? So in this case, I just return original value always. Right? And otherwise, so like over here, right, I'm creating the new variables, new not inferred. But this substitute the temporal, we already know about this because this is like what we are going to we're going to unite the actual inference with that. Context subs add var sub temp. Yeah. I guess this also like the recurse IDs are also not necessary anymore. So we just say that sub temp. This is new not inferred. I need to like get the variable here. Let's use all of these and call this sub temp var. Sub temp var is sub temp get var. So just say sub temp var inference var remember subbed in scope ID, right? And that's all. Do you think this is going to work? Let's see. Examples hello. It looks like this did not work. We still went too deep. Do I create the new ones? Well, I mean, not only that one, right? Also this variable, hold on. The original variable that I have also should be remembered, right? So like I basically, well, no, not the original variable. Wait, what? Wait, we have like more like that. Recurse ID server temp. Wait, what? Hold on. Recurse ID depth. Wait, is this not even breaking the recursion at all? Once this is inferred, I substitute that, and then I unite. Oh my god, why is this so difficult? Was subbed in scope ID. Like, because I always create this new variable, right? No pain, no gain. Yeah. By the way, I ordered the microphone that you suggested. It should be like here in a couple days. I don't remember what your microphone sounded like, but hopefully it sounded good. I don't remember though. When do I stop? Like, I know that this is subbed. New not inferred. New not inferred is only called over here, right? Yes. It is only called here. When I... So, like, this is the temp, though, right? This is the temp. And then this is my actual var. Wait, hold on. Yeah, I have this CTX subs. Oh, yeah. I'm seeing if I have tried substituting this variable before. And then I just return that. Var. Okay. All done. It's because I'm still creating the new variables somewhere, right? I'm still creating new variables which don't know if they were substituted or not. Yes, of course. Of course, that's what I'm doing. Once this is inferred, I'm doing the substitution. Yeah, over here. This is the substituted, and I'm unifying this. But this substituted thing creates the new types, right? For sure, it creates new types. Like, and then I need to like remember for this sub that it's also substituted. So this is the actual substituted, and this is the temporary substituted. Okay, let's try this here. Subbed get var subbed var but subbed var is get var subbed. Okay, is this going to work? Please work. Please work. Oh my god, no, it did not work. All right, what next? What next do I try? Let's do this over here. Log info. Subbing var log info. So we are literally creating the new variables all the time, right? Camel run param is nothing. There we go. So yeah, here's what's happening, right? We are creating the new variable, and then I substituting it, and then we are substituting that variable, which is new, right? But like, what's the scope in which I am substituting? That's the question, right? Because this new variable that I created, let me print the scope. Is this print span? I want to print not this span, because span is fake anyway. I want to print id print scope id. That's what I want. There's no way I'm having. So I have two scopes, right? I have scope 3250 and 3257, which is like the two scopes of the two generics that I have. You think I'm on the right track? The Go rewrite of TypeScript also uses a recurse ID. They call it recurse ID too? Okay, well, I'm onto something then. It's curse. It's cursed IDs, though. I think... So like we have two scopes, right? I remember this in one scope, and then the other one is in the other scope. So when I check that this other one is in that scope, it's not, because it's in the other scope, you know? Yeah. Yeah. Whoa, but, hold on. Shouldn't it be like when I'm creating this new variable, right? This is the new variable that is the result of me substituting this one, right? But this new variable should, like if the original variable was already substituted in other scopes, then this new variable is also substituted in the original scopes. I think that's the thing that I should, right? So I should not remember this new scope, right? But I should remember also all of the original scopes, right? Oh, I think that's correct. So remember subbed from another variable, from a variable which is my original variable, which I'm trying to substitute, right? This is a variable, and I do the same thing here. Subbed from the original variable. I think this might actually do it. Trust. Remember subbed from. So this just takes not the ID but another variable, right? But another variable. Remember subbed from. So we have two variables. This is the variable from. So I will say that from is find root from. And then this should be ID set, not add, but like now just union of this. And from subbed in. All right, now it's going to work for sure, right? Please work. First try. Okay, it worked. It seems like it's a little bit incorrect though, but I did break the infinite recursion for sure. But why is it like a field? That's the question. That is the question. Okay. Let's go back and remove log info. Back to trace. Okay. Restart language server. So as you can see, this, right? So like, let's act this. That's a bad idea. Let's go into construct the shape. I mean, if I have the reference here, though, I can have a like reference over here, for example. Doesn't really matter. Yeah, and then I can do this. So what is this type, right? Wait, this is actually correct, right? This is actually correct. Because it's a reference, which, like, yeah, because this original thing is not a reference. It's just a tuple because this is A, not B. But if I say B, it should be just recursive originally. Yes. Wait, hold on. This is actually correct. Why did I say not correct? Because this? Bro, there is no way you use this extension unironically. Which extension? Which extension are you talking about? This is type. Field is that. Wait, is this correct? A int 32. So A is a thing which is a type which contains BT. BT is AT, which is supposed to basically contain itself. It's not recursive here. Oh no, it's David KMGBA. Do you know them? Is that your friend? The sparks flying? Yeah. I don't even notice that anymore. Do you not like it? I don't even see it. This feels incorrect because this is a recursive type which contains itself, right? Because BT is literally AT. Like if I say that this is AT and then I print it, right? This is still not looking the same. Why not? Like, why is it not the recurse over here? That's weird. Because, like... I put that extension on people when they leave their laptop on for lunch break longs, along with Fibonacci tap spacing. Is T-type parameters? Yeah. It's not exactly type parameters, it's just generic parameters. It's not necessarily a type. This can be any value. In this case, it's a type, because I'm trying to construct the types, but it's not necessarily types. We have a general purpose. Like, we have, like... I don't treat types as special. This could be like for example, fixed sized array. It's not a type parameter, it's a parameter. Fixed sized array has the parameter which is n, which is not a type. This is going to be an int, right? Which returns a type or whatever. And yeah, it's a generic parameter. Types have type parameters. Yeah, but this is also not necessarily a type. Like when you have a generic functions, which one of them are generic parameters and which one of them are function parameters, you know? When you have function foo, which is like t x t into x, right? This is the ID function. Like, what is t in this case? What parameter is that? That's the generic parameter, and this is the function parameter. key itself is the type parameter. In this case, this is the generic parameter of this generic function, right? Because this is not a type. This is a type. This is not a type. But this is only a type because I'm using it in the type position. This is not necessarily a type. If I say that this over here is x, which is int 32, and I return like x plus x, then this is not a type parameter. This is just the generic parameter. Like I don't know why would you like write something like that, right? But like you normally do use this for const generics, and yeah, this is just a generic parameter because this over here is a generic, and this is its parameter. Why do you call it type parameter? Because the generics are not necessarily types. There are generic functions, generic types. There are a lot of things that can be generics. There can be generic generics, right? Okay, I have like just a slide. Okay, let's just ignore this. Let's pretend this is correct, which it is not, I think, but maybe it is. Who knows? Let's first try to bring back the standard library collections and see if it works there too. Blocked value shape, k is not k. K is not k. Blocked value shape, k is not k. Oh wait, did I not wait? Am I doing the substitution right now? Sub mode. Is it called sub mode? Sub mode, type only. Can I do full here? So it's full or none when I call the function. But when I instantiate generics and do the type inference, I'm doing it all. Okay. Let's see now. Locked value shape. K is not equal to K. TypeScript does not even allow T2T. Generic is just type constructor, right? Not necessarily. It does, like it constructs something. It's not necessarily a type. Generic is like a function. It's almost no different from a function. It has different syntax, and it's also subject to inference, which means that you can, fully infer and skip the arguments of the function. But other than that, it's just a function, which means that it has arguments, and then it returns something, and whatever it returns depends on like what function are you writing. So a generic type is a function from whatever, from a type, and that returns a new type. And generic function is a function which takes like generic arguments and returns the function, the concrete function. Right? If data value key. So like we say that k is not equal to k, right? Because these are two different k's. This is k2 and this one is k, right? K is not equal to k2. But why is that? I'm not substituting somewhere now. It is what it means. I feel like this should work. So I don't have infinite recursion. But what is the type of a map here? Okay, so we see the issue here. This is a reference. Can I say new type here and say new type here? I feel like I can do that. So yeah, map is the map K and V. and this k is not equal to k. Let's okay, let's rename this to k add. So this has type k add and v, and k is not equal to k add, blocked value shape. We need a counter for how often you broke the type system, type inference. I feel like it's always like because of the substitution, this stupid substitution. Maybe I actually fixed it this time, right? It feels like my solution right now is less hacky than it was before. It is almost like, so the ideal solution is not what I did, but it is semantically similar. So we remember in which scopes we have substituted the variable, but we could do it like faster. Because we could, like, when we basically want to go from one scope to the other scope, and like the type should be like writable in both scopes, which means that it should be writable in the lowest common ancestor of the both scopes. So yeah, something like that would be the solution. But we basically instead remember in which scopes we do this. So I mean, it achieves the same thing semantically. I think it's just a little less efficient potentially, which probably doesn't even matter. So maybe that is the solution, I think, if that makes any sense. So I fixed it. I didn't break it, but I didn't fix all of it. It seems like maybe I missed some place, because k is not equal to k add, right? This is k add, and this is and k is map t, like, right? This is this over here, something. Okay, let's try to create this in I'm going to comment the collections again, and I'm going to try to make this in hello. So we have mutual recursive types a and b, right? And then let's say mutual recursive types. Now let's do this. A is, let's say, option AT. How about that? Option AT. No, not option. Maybe A is like I want a type that I can construct, right? What do we do? Like singly linked list, right? No, but we want mutual recursion is the thing, right? So we have like yeah, we have basically a singly linked list which alternates the types of the nodes, you know? How about that? So we have A, which is going to be, you know, which is going to be like either nil or cons BT, right? And we have a B, which is basically the same, nil or cons AT, right? So if I try to print this, type hello A int 32, right? So can I say that let x, which is A int 32, is going to be equal to nil, dbg print x. Okay, so this is nil, right? And then we say like cons nil, right? So this should work. This actually works. We can also say that when we cons, this over here has value like a t, you know, and tail is this. We can see that this is cons, where b is t, and rest and like tail is at. And then we say over here cons. So since this is A is 1, and then cons B is 2, and tail is nil, and tail is this, right? So this type checks, right? There we go. This type checks, it runs. Okay, so this is B, this is A. I can go like, I think this works. So I want to have like a generic function now, right? Const foo is t, where we have like list, which is like AT, and then this should return BT, option BT. I don't know, let's say tail, tail of A, you know, something like this. So we're just going to like match list with, if it's nil, then we return none, and if it is cons a tail, then I just return tail. I return like some tail, right? Okay, so now now there's some problem here. Option BT, expected a generic, got error. We have everything that's available, right? What's the problem then? Expected a generic. So option is not a generic? Oh, wait, yeah, it's because it's option T. All right, now. Fuck, this works. Wait, what doesn't work then? How is the map different? Hold on, this is working. This is working. How is map different? Let's try to minimize the map example. Let's try to minimize the map example. This is because I'm instantiating this with another instantiation of the generic. Is that the reason? Hold on a second. How about we say that tail over here is like, for example, option AT, right? Option TAT. How about that? So when I say the tail of B, this should be like none, you know. Does this work? Stack trace while compiling. Exception went too deep. Wait, hold on. I went too deep again. Okay, this goes too deep. Oh no. We have infinite recursion again. Where do I have infinite recursion though? Is it like here? No, it's when I'm instantiating something. Well, I'm doing this when compiling. Can I like comment that? Yeah, if I comment that, then it's fine. So it's when I'm saying this. Then yeah, maybe like. So list is A, and this returns B. Option T, BT, TBT, TBT. Can I use inference here? Potentially. If I use inference, then it works. So this returns hello, none, or some hello. Right. None or some B. Yes. Which is basically an option. Right? Okay, wait, hold on a second. I think I know. It means that the problem is where? The problem is when I do here the this, if I do this as comp time, maybe? No. Option TAT. No, that doesn't make sense. Like, what's the difference here? What's the difference here? Can I say const underscore option TBT? Well, I mean, T. Can I do that? Wait, why does it say that this is hello A? Isn't this B? Didn't I say B here? But it's printing this as A. But this is not A, obviously, right? This is B. What's the problem? I need to stop streaming. This has been too long. What? 8 hours? What? I cannot do this right now. It seems. I'm so close. Though. Alright, I cannot do this any longer though. A nice long Kubi stream. I should have stopped like 2 hours ago. Let me like at least, I mean, I'm going to continue with that, right? But a lot of these things should actually be committed. The only thing that I'm going to do, I guess, is so like sub mode over here, which is full. This is going to be type only. And over here, it's going to be function only. But we're going to undo that. This is going to... This is going to no... Yeah, this is not infinitely recursing, but that's different. We have someone treat who made the game dev on Linux. There's Fairmont. Fairmont also makes like their own stuff, right? Like their own program, like everything from scratch. Oh wait, there's Batcop. Hold on, no, we're at Batcop. Batcop is cleaning code. Imagine having clean code. All right, hopefully next time I actually finish, or maybe off stream I will finish the higher kind of types. Bye.